And so these recordings that we'll be making throughout the program, I'll make them available to you in this folder and in this recordings folder, which I will be placing in a particular folder here. You should also have a link that will basically share. I'm going to share it with you. So the recording link is coming to you. I'm going to copy that link and I'm going to paste it in Slack chat. And what this will do is get you a link so you can download the recordings whenever they become available. So as soon as I finish the session, I will save my recording in the same folder. They will automatically become available to you locally. So that's one thing. The second thing I want to show you is this other aspect of Scratch, meaning anytime you want to save something or write something or share something with other people in the class, in the program, you will want to save it in this different location in which I'm giving you read and write permissions, which means you can delete stuff, which means you can modify other people's stuff. So please be careful as to what you're doing, but you have write read permissions, and I'm going to paste that link again in Slack chat, and this is the link to get access to a folder which is our Scratch folder, and this is where I will be posting whatever I want to share you. You can also post back to me, and that's how we'll be exchanging our content based on what we want. So if you by chance get any issue with the GetSync software, just ping me on Slack chat. We should be able to fix that one easily. Having said that, we discussed VirtualBox, the machine itself, the Slack chat, the access to this particular cloud technology segment with an introductory module about introduction to cloud computing. Why do businesses care about cloud computing? There are lots of material here. Some of these videos and some of the content here can be primitive to you. I know you have experience. You have tons and tons of work experience. So you might find some of the early items a little bit, I would say, simple. Let's call it that. So if it is simpler, we can expand the idea, and we'll probably not cover simple things in the program itself, because I would like this program to be meaningful to you, which basically boils down to the fact that if I am boring you at any point in time, if you think that I'm boring you, you should absolutely tell me that, you know what, Nilesh, please stop boring. It is not interesting. So please increase the level of engagement, increase the level of content, the depth that we want you to cover. You can tell me anytime that this is too trivial, too simple, and I can absolutely increase that. That's not an issue at all. And this content that you have in the, at least in the cloud technologies portion, is meant and geared towards those who have no idea what cloud computing is. Basically, that's what. So for beginners, there are some content available on the internet in this particular location where you go to cloud technologies, where I'm actually looking at beginning from the module number 1. Some of this section I will basically very quickly cover it, but not take too much time into going detail into very trivial things. So having said that, if you feel that there is a need for me to go deeper, please tell me so. But I want to actually begin at this moment, and anytime if you need something, feel free to speak. The mics are open, but please don't make noise for other people. So just be cognizant. There are lots of people we have here right now. I think we are approaching 10, 9 at this moment. We have 9 people on the phone on the meeting right now with me, and so let's begin.
Hang on a sec. I thought that this was supposed to be a session just for HDS.
Not really, because we expanded it. Was that David?
No, this is Patrick.
I see. So we had this concern of less than 5, so we included other people in this program.
So, yeah, we probably should have talked about that, but now's not the time.
Okay. So we can figure that one out later. Let's talk after this session. We can adjust that. Not a problem at all. So let's. I think for now, let us continue. Let us talk after the session. Right, David?
Yeah, now's not the time.
Okay, good. So let's continue for today. So let's begin with the core topics that we want to cover today, and that we'll begin with what is cloud computing, why do businesses care about cloud computing. We'll also go over the formal definition that NIST has defined. So if you know this agency that U.S. government has stipulated, the National Institute of Standards and Technologies, this institution basically allows us with in this country to set standards about whatever this country wants to follow. So one of the things that this agency has defined is this cloud computing as a definition. And so they have given a 25-pager definition on cloud computing. And so here it is. And so I'm going to drop a link to that. And on page number 8 of this item, you will find, it's a good bedtime reading, by the way. And so in this definition of what cloud computing is, it goes over some of the specific things such as the key characteristics. And of course, the description and the actual definition is fairly elaborate and fairly comprehensive that they have provided us here. However, I'll be not reading through the actual definition itself, but highlight some of the key characteristics of what cloud computing is and how is that different from setting up your own data center, if you will. So we have people in this group right now who have experience in hold on, let me adjust my screen so I can share my handwriting with you. And where did that go? Here. Yeah. So in here, I know we have people who have built and created and actually sold infrastructure. We have infrastructure people here, primarily the folks from HDS. They what you know better than I do what you do. But primarily, I know that you are in the business of selling infrastructure to companies, and the businesses are evolving over time. When I say infrastructure, you can broadly classify into 3 buckets. We have CPU or compute power. We have some network capabilities. We have some storage capabilities. And so these are the broad classification of resources that you can have that will help you build some kind of a data center. And so when people talk about resources, that basically means some infrastructure, some form of resources that helps you build a capability in your data center, either in your company or outside in the company, in some co-located space where you provide resources and then you make use of these resources. So that's the classic data center model. However, the concept of cloud is somewhat different in that there are 5 key characteristics that, according to this definition that NIST has provided, that is different from a standardized data center. And one of them, if you begin with the actual definition, it enables ubiquitous, convenient, on-demand network access to a shared pool of compute resources. And that basically can include network, server, storage, application services, whatever you have. And the key aspect here defined is on-demand self-service. And that is probably trivially simple, but it is available to you on demand, meaning you can just go to a service provider just like this and log in, and on demand just click a button and log in, and then on your will create a machine that you like by giving it a name, clicking a size, and selecting an OS, selecting a particular key that you want to use, and just click the green button to create a machine on demand. And that's what is basically meant by this definition, which is on demand. And self-service, meaning I don't need to call a particular company and say, hey, can you please give me a machine? That part is completely driven by me. I don't need to engage with them, don't need to create a support ticket, or don't need to call somebody. I can just, on a self-serve model, on my wish, on my need, whenever I want, just get the resource I want, get the resources provisioned for me, dedicated to me, and start using it almost programmatically. So in this interface that I was showing you is a service provider called DigitalOcean, and that allows us to do the same thing. By the way, all other cloud providers that you see today, like for example, this company very well known for cloud computing is called Google Cloud. This is the Google Cloud interface. We have another well-known company called Amazon Web Services, which is on this page. You have Amazon Web Services showing up where you need to sign on, and you can do pretty much the same thing, except my signing on process is a little bit more complex than just entering a password. And are you familiar with what I'm doing right now? Do you know what this thing is? like what am I doing at this moment?
Yes.
Okay, so this thing is called second factor authentication, or 2FA, and this is where I'm typing a second layer of security to allow me to get in. And this is where I'm in now inside the Amazon cloud, and here I have the Google Cloud, here I have the DigitalOcean cloud, and all these cloud companies are providing me resources on demand whenever I feel like, without me going here and calling them. It is basically self-service. I can get my resources anytime I want by just going there and say I need to have an EC2 machine, so launch an instance, and I want to select Ubuntu OS, and I will select a particular size of the machine and say configure the details and add some storage, and then I tag the instance, create a security group, and off we go. And so then I review and launch. As simple as that. And so it's a very trivial process to actually create a resource available to us, as opposed to asking and doing the same thing in a data center where you have to go and buy some hardware, buy some compute power, buy some storage, connect them together, configure them, connect them through some kind of a network, and make that available to your audience, to your customers. And all of that takes a lot of time, a lot of effort, a lot of processes, a lot of money. And all of that has been cut down into simplicity by on-demand self-service. And this is the primary attribute of cloud computing. It has to be on demand. It has to be on a self-service basis where people can either go to a site or programmatically access through an API and make that service, make that resource available to them. Next one is broad network access, meaning the assumption is that the end users who have access or need access to the resources have a method of connecting to the resources wherever they have. So they can either use some interface such as their mobile phones, laptops, tablets, workstations, wherever they are, or a browser on some other thin client, and connect to and access the resources they want to consume through the cloud because they have that network access. Another key attribute here, which is resource pooling, and that is the idea of making sure that people who are on this particular cloud, you can also create a account on the same cloud and actually make sure that you are consuming the resources that this company provides you. And by the way, it may be the case that when you have a machine created in, say, this DigitalOcean cloud, which happens to be in New York and San Francisco and Toronto and a bunch of other places. So in any of these places, such as, say, San Francisco, if you have that DigitalOcean cloud account, in that San Francisco location, you might have multiple data centers. And within that data center, you might have multiple floors and racks and racks of machines. And these machines will have one such machine that you will instantiate using some API call or using some browser access. You will start a machine that happens to be sitting right here in this location. Your competitor in your company that competes with your company can also have another machine potentially in the same location in San Francisco, in the same data center, in the same floor, in the same rack, and even in the same box, that neighboring box, or in the same box, he or she might have their resource right next to your machine running on the same physical box. That is a highly, it's not impossible. That might happen, which basically boils down to this idea that your resources are shared among a multi-tenant model, meaning the providers who are providing you this resource from any of these providers in the public cloud domain, you will see that they are basically sharing the back-end resource with somebody else, with the public at large. And that is a thing that you need to very clearly understand, that public cloud providers will share and will have multiple tenants on the same infrastructure, where people will be joining the same infrastructure and sharing resources with you. And the next one, the next key characteristic is rapid elasticity. And that basically essentially means that if you today want one machine, like by the way, in DigitalOcean, these guys prefer to call it as droplets in the DigitalOcean. When by droplet, they actually mean a virtual machine. Or some other companies will call it Amazon Web Services, they prefer to call it as instances. And I think Google uses the same name. And so these are basically VMs that they give you depending on the size of the VM you select. And you get to select a machine, and you can then start them up. And so the idea that we are discussing next is this concept of rapid elasticity, which basically boils down to growing and shrinking. And when I say growing, I actually mean, adding one more machine. So you have multiple machines. You can keep growing and add the number of machines that you are dealing with by adding on to the existing infrastructure. So for example, here you have, let's look at the pricing page we have somewhere. And so the pricing of these machines is very, very simple. So you have to get a small size machine. You can pay $5 a month, and you can get 512 MB RAM, 20 GB SSD, and 10 GB of network transfer. And that's how you will, pay $5 a month, and you can scale or grow by adding in two different directions. And that concept of scaling is, in my mind, and different people call it differently, but the scaling can happen in two directions. The two directions are, one, you can scale like this, go up or down. And another way of scaling can be horizontal, meaning you can go scale out and scale back in. And so this up and down scaling is one way to scale. In and out scaling is another way to scale. And by in and out versus up and down, what I mean essentially is when you are scaling and getting a bigger machine, so say from 512 MB RAM, you jump to 1 GB RAM like this, you're paying about double every month. So you're paying from $5 up to $10 a month, but you also doubled your GB in terms of RAM. You increased your SSD capacity. You also got a lot more transfer on the network. And you can go like this and go even bump it higher, pay more money, but you still get one machine, which is a bigger machine. And that idea, what I prefer to call, is called vertical scaling, when you're actually getting a bigger machine. So instead of a 500 MB RAM machine, you get a 1 GB RAM machine, or you get a 4 GB RAM machine, or even higher. And so this, when you scale it like this is the concept of vertical scaling. And when you scale back down, you actually have to shrink the machine size down to a smaller, and that can be a bit difficult if you have constraints on the application that is running already on a bigger box. You cannot just shrink the box. And that is one way to define in terms of scaling up versus down, and that is not the most popular method of scaling on the internet. In the cloud, the most dominant way people end up scaling is actually this way. And what does that mean is that you have one box containing your, say, $20 per month. Then you add one other box, $20 per month, another box, $20 per month, and you scale it like this. And there are methods of scaling this way out versus back in. And that method of scaling is extremely popular in the cloud, where companies can scale out their infrastructure and scale that back in on demand. And that's the attribute that this aspect of the definition is trying to describe, is rapid elasticity, where you can easily provision and release when you don't need. So that release aspect of when you don't need a particular resource, you can just let go. And that letting go can happen also dynamically. So dynamically as in, you can either go back here and deal with it from a machine perspective. So I actually have a machine running here, and I can go to that EC2 location and see my running instances. So you can see that I'm running an instance here, and I can let go of that instance. It is running right now. I can just right click on this machine and say, go bye-bye, and the machine will disappear, and it will reduce my bill. And that is a valid way of getting rid of resources when you don't need them. So you're basically scaling back in this way and are getting rid of the extra machines that you don't need. And that kind of elasticity of being able to grow out and shrink back in both constitute horizontal scaling. And that is very interesting from an economic perspective. The scenario goes something like this. When you have a business that let's say, you're starting a new company and you have some infrastructure you want to put in place. You have customers that you expect to see, that customers will arrive on your site, on your company's infrastructure will get hit because your customers will be visiting your site. And imagine if you're, say, something like a new Amazon.com, right? Not the Amazon Web Services, but the Amazon.com retail. So imagine that you are that new retailer and you are putting infrastructure, and if you want to build your own data center, you will end up spending a whole lot of money upfront. And then over time, you will keep some money spending on expenditure on your maintenance. And so there will be some ongoing cost towards what you're doing. And so this is the cost structure that you will be spending over time. As you know that you will you'll get your customers hitting your site. I'm just calling your site, Amazon.com, but it could be it would be your company, your retail company. And so come January timeframe, you know that the business is going to slowly pick up, but over time, as it comes, say, Thanksgiving or Christmas timeframe, at that time, you know that the business is going to get hit hard. And so the scenario that becomes difficult is to be able to predict correctly how much data center capacity should you put in place upfront to become ready for when the actual demand is going to hit Thanksgiving and Christmas time. You're spending a whole lot of money upfront. So imagine this other situation where you don't actually spend up a whole lot of money upfront, but instead be agile, be nimble, and actually start very, very small. And so you basically are able to not predict how many customers will come, and so you grow really, really small. And as you see that your customers also come, and they will buy stuff from you and generate some revenue for you. So that revenue, I hope, is more than what you have. So this is the revenue stream, and this is the cost structure. And so I hope that your cost structure will be below your profit or income inflow structure. And so you will end up making this profit that you will likely to have, even if your demand from customers can go up and down depending on what that cycle is. You can always, grow your infrastructure rapidly along with the customer demand. And at this moment, when you see that the demand is not so much, you can actually shrink it back down and actually map it according to what that need is. So at this moment here, you're actually growing your infrastructure. And at this point here, you're a little bit shrinking. And you can do that this way if you have this elastic concept of being able to create a machine whenever you feel like, being able to release the resource that you're not consuming, and that ability to be able to grow and shrink. Always have a decent estimate of profitability. As to when will you hit profitability is kind of hard to guess here. You don't know when the customers will come and how many will they come. And so you have the same curve here. You cannot really tell when you will actually hit profitability because you have already spent a whole boatload of money up front, and you're waiting and praying for the customers to arrive, and it does not give you that agility, that business agility that is expected of you. And so that aspect of rapid elasticity is a critical aspect of cloud computing. And the last one is measured service. And that bottom line basically means that they will give you a bill. So you are going to consume the resources, you are going to get a bill. And that bill will look something like this. You have this, whatever size machine you will buy, and spend, say, $640, 640 per month. You will get a 64 GB, 20 CPU, 640 SSD, 9 terabyte transfer machine. And you can make use of that machine, and you can buy any number of any types of machines that you have from this particular cloud provider, and that's what you will get. On the contrast, you have, different companies have different pricing models and different methods of paying, and I have some charge here accumulated from this company. Was there a question? No, I'm getting some echo. So the thing that the key characteristic that you saw in the definition essentially are on-demand self-service. So basically, get the resource anytime you feel like through an API call or through a browser access, available to you from wherever you are. Sharing of resources, meaning your competitors might be on the same physical box that you are going to be applying your applications to. So we have to keep. Go ahead.
I think there's another important aspect to this is that as you scale up or scale out horizontally,
Hmm.
depending on how far you scale out, your costs can be, if not the same, if not more. I think that's something important to point out. That depending on the size of your operation is going to determine how much your cost is. So even going with cloud in this type of environment, even with elasticity, over time, if you're constantly growing and you're getting bigger, you're probably going to spend more money. And I think that's an important point that a lot of people don't get when they actually look at cloud.
Right. In fact, that is a valid thing. The aspect that I'm probably trying not trying to paint a rosy picture, but the fact is that there is this flip idea that you just brought up, which is also important. If you know that you need to have a bare minimum volume of service level that you need to provide. Let's say, draw the same picture here. You at least need this much all the time, right? That capacity to serve customers. You know that your customers are going to grow eventually. They are not going to shrink down below this chain, below this line. So you know for sure and almost guaranteed that there is this need to have this particular level of serviceability in place for your customers, because that is a given. You're never going to go below that. And at that time, this economic condition kicks in, and that is very, very simple. The idea is that you don't need to be able to like go dynamic in terms of your demand, and don't need to use the aspect of elasticity, because you know for sure that I need to have at least 30 machines at any given time with 4 GB RAM already, and that's a given. For beyond that, if I want to scale out or in terms of the demand from customers, I can adjust that scalability, but I need to have at least 30 machines all the time. In that case, there are some crafty economic principles come into play, and there are two ways to thinking about it. One of them is the classic old style. I need 30 machines of 4 GB RAM each. I'll just buy them outright purchase, and that is valid. Another approach to dealing with this problem is that you might want to actually negotiate with your cloud provider and have them give you what is known as a preferred pricing. And so there are actually three types of pricing available in Amazon Cloud, for example. Let's go look at their pricing model. Amazon has three types of pricing. So I will call them the three models of pricing. Is this one model is the one that you know already. It's called on demand. So you get a machine, you pay for it. That's the price. The second model is called a reserve price. So this reserve price is what I would call it a commitment price. So you commit to buying something, and when you commit to getting, say, 30 machines of 4 GB capacity in terms of RAM, you're committing to it for a long term, say 1 to 3 years. Then you get a special commitment price. And there is a third model also, which is this thing is I call it the eBay style pricing. And this model of pricing is they have a formal name for it. These guys, what do they call it? Okay, let's say spot request. Yeah.
Instances.
Sorry.
Sorry.
Yeah. So this thing is called the spot instance marketplace, and so in here, what they have is eBay style pricing. So this is conceptually similar to the idea where you have, let's say, I'm a plane company, right? So I am Alaska Airlines, let's say Alaska Airlines, and so I have Alaska Airlines flying from Seattle to San Francisco, and I know that the ticket is available to buy, but the flight is in 3 days from now. So this is now, and this is now plus 3, and so the flight is at that time. So I have a ticket price set, and that's my price. And over time, from between now until T plus 3, when the flight actually happens from Seattle to San Francisco, my seating and seat pricing that I have in place, I will have to adjust that pricing depending on the demand for that particular seat. And at this time called T plus 3, when the flight actually takes off, a few, some time just before that, what is the value of the ticket? The value of a seat. How much do you think it is? If somebody wants to go, there is a reasonable value associated to that ticket. So I can actually charge some money. But if I know that there is the three guys sitting in the ticket counter waiting to see if there is a cheap ticket available, does the airline think rationally that I should just let this ticket go for, say, $50 and let this passenger who's like loitering around in the ticket counter, let him fly at a rate of 50, whereas this price was like, say, 199? Should I allow that? And that boils down to this question of what is the cost of my whole bag of peanuts, right? I have this bag full of peanuts that I expect people to finish, and that bag of peanuts and some Coke, half bottle of Coke. So that's the cost. There may be some cleaning cost, right? So that's the cost to running a extra seat of a passenger going from Seattle to San Francisco, and that cost is what I am going to incrementally spend on an additional passenger on a $50. It becomes still profitable if my cost of a bag of peanut and some Coke and some cleaning and all that turns out to be 30, and I sell the ticket for 50. I still make money. Between 50 and 30, I make $20. If I don't sell that last seat, what happens is that at this moment, after the flight goes away, the value of that ticket is zero. And so there is money to be made if you allow that last passenger in. And that's exactly what this eBay style pricing that I was mentioning, which is called spot pricing, is what is going on here. When you request a spot instance, you can say that I want a machine running spot instance from Amazon, and you say select, and you say that I want to get a M3 large machine. So I'm going to select this particular size, M3 large, and then I will see what my spot pricing turns out to be. So I'll go click the next button at the bottom and see that my pricing is available right now, right here. So if I want to go to the particular US West 2A, I have my pricing as 1 cent 68. If I go to US West 2B, I have my pricing set at 1 cent 63. And in West 2C, my pricing is 2 cents 46. And so this is basically a dynamically generated price. The regular price is actually a lot more higher than 1 cent 68. I mean, this is 1.68 cents per hour of usage. So it's pretty dirt cheap. Why is that cheap? Because Amazon has enough capacity left over right now to give us those customers who are like loitering around at the ticket counter right now. I want to get on the plane, give me a seat for $50. They might sell you. And that is exactly what's going on here, where you can get a spot instance. But the challenge with getting a spot instance is that they can kick out anytime they feel like. They can just kick you out. And they can do that by dynamically adjusting the price. And so these types of machines that you get on spot instances are useful, but only for when you know that you can be kicked out. So there is no commitment. And so it is just unused capacity they are trying to make use of, and allowing the last passenger at the time to take the plane in the context of a cloud computer situation where you have some resources available for you to let go of people at a throwaway price. And that is what this thing is. Spot price is another model of pricing. But these three are just the Amazon way of pricing. In Google, they have another model. If you go look at Google's pricing, they will charge you and they will give you this retention discount automatically. So if you try to, like this reserve price or commitment price that you make, if you go look at Amazon's pricing on a similar structure, let's identify a particular model. Let's see if we can find the actual price numbers. M3 medium price. And so instance type and M3 medium pricing is coming up. And let's go look at what pricing do we have from on demand for the same region I was in Oregon, US West 2. And I have the M3 large pricing here. And that pricing turns out to be 13.3 cents per hour. And that is different from what we saw earlier in the spot. Right now, what we are looking at is a price of 13.3 cents, whereas in the spot market, the price was 1 cent 63 was the lowest. And so it's a dramatically different price in the on-demand versus spot. And that is possible because Amazon is discounting dramatically to let you use the unused resources that will otherwise go waste, unused. And so that was the spot price. Let us also look at the commitment price. If you go make a commitment, their pricing is typically about 30% less than the on-demand. We can go and examine that as an example, see if we can get some on-demand pricing. So you can say reserve instances and say I want to purchase a reserve instance. I want to go T3, N3 medium, N3 large, and the availability zone I want is 2A, and let's say for any term, 1 to 12 months or 13 to 36 months, and I'll say search. And here's I'm getting some pricing information. Here I have for 36 months, the most effective rate I have is, and so what we are looking at right now, if you pay it all upfront, that's the best rate you can get. And you're looking at a price of 5.2 cents for a reserve price. And so when you know that you need a certain number of machines, like 30 machines at 4 GB capacity outright perpetually for a foreseeable future, like 1 to 3 years, you can either buy outright, or in certain cases I have seen many companies already have the infrastructure, and so they might want to actually keep that in use. The challenge becomes, how do you actually take the existing infrastructure that you already have in-house and have the additional need for your servicing your customer base, like I'm suggesting here in the example, where we have some capacity in-house, and for extra demand that we get from customers, sudden burst, so there is a constant demand we might have be able to serve, and then suddenly this Christmas season comes along and then it goes away. And so to address that Christmas time, we need extra capacity of horsepower, some resources that we need to provide, and our in-house data center can deal with only this much and not more than that. And in that case, what we need to be able to do is to make sure that we are ready to, what I call, burst into the cloud. And this bursting into the cloud is possible if you program it correctly, if you have your applications written in such a fashion that they are compatible with what you have in-house. So this is the in-house portion, and whatever you want to burst into the cloud, you need to write your applications in a fashion that they can breathe into the cloud and then breathe, inhale, exhale out of the cloud as you need to, expand into the public cloud, come back into your internal private data center you might have. And that is a complex method of programming, but we can discuss, we will discuss these things subsequently in through the series of sessions. But the core idea that I think the person who mentioned this idea about how much you have on a fixed basis, you want to make sure what you already have in your in-house resources. So consume whatever you already have and compare that with the other two choices, whether you want to buy stuff outright or otherwise go a commitment price, or sometimes you go on demand based on how much immediately you need those machine sets. And so depending on what the pricing model might look like at that given time, it might range from something like a 13 cents all the way down to 1.63 cents. And this has a risk. The risk here is that the machine can be taken away. The spot machines can just disappear out of your control. And if Amazon needs that machine back, they will just bump the price up. And if your price does not meet that threshold, that machine will be taken away. And so it's a risky model where the machine can just go away from you, and you don't want that. But then there are certain use cases that we will discuss that actually apply and that people make use of. And so that is also a valid model, but most companies, if they know that they need something, they typically go this route, or they need on demand, they just go this route. And that's the concept that this definition also validates. Having said that, are there any questions in the characteristics that we just discussed in terms of what cloud computing is according to NIST?
Nilesh, I have one. Thanks, Echo. Sorry. You guys hear me echo, or is it okay?
If you're hearing echo, I think it's best to use a headset. If not, we'll have to fix that.
I'm using a headset.
Okay, go ahead.
Okay. So with
So with
respect to what the
gentleman
the economic scenario, and if this is too premature or not appropriate for this point, you could just, I ask it, you could just defer it to a class or offline. So you gave us a two outright purchase and co-locate or whatever. Another one is Amazon or Google or what have you. How about two options where a provider manages and or say VM, for instance. Where do either of those scenarios? And if it's too appropriate.
Can I know, is that Ted speaking? I'm not able to hear you properly, Ted.
Yes.
Yeah, I'm not able to hear you properly. Can you also type your question? And in chat, better to type your question. I'm not able to hear you. I think let's deal with the audio problem later.
Okay.
You can always dial in.
Yes, if there is an audio problem, it's better to use the phone capability as opposed to voice over IP capability. So there is a dial-in option.
And I'm actually dialed in.
So if you need the dialing in information, please refer to the Slack chat. I have a bunch of phone numbers.
So that suggestion is going to work. I'm dialed in.
Okay.
And I'm getting the echo.
Huh. Okay. I understand. I will deal with the echo issue later on. Is that okay, Ted?
Yes, sorry. I had on you. Yes.
Who else is getting echo apart from Ted?
David Robinson. Can somebody
We're
else?
all here.
Yeah, everybody's here.
David, are you consistently getting echo anytime you speak?
Yes.
Okay, hi guys. I think if you see echo coming in, I suggest all of us mute except the active speaker, which at this moment is me, and unmute yourself as and when you need to. That will be awesome. Or I can help you do that.
I think the problem is you're causing the echo.
Am I causing echo? Huh. Okay. If that's the case, I will have to use a headset myself. Hold on.
Nilesh?
Yes.
Put your phone on mute for just a second.
I heard you say put myself on mute. Okay, I'm muting myself.
Okay. So this is a echo test. Can you hear me? So yeah, it's you.
We can hear you.
I think David just confirmed it is me. So yes, I am causing echo. Hold on, let me fix that. Yeah, David just confirmed that. So yes. Okay, now you should not get echo because I'm not using a.
This is an echo test.
Sounds good.
Yeah, let's go around now. So, what? I guess it was Tim that was asking a question, or
Ted. Yeah. So my question was, and if it's inappropriate, we can defer it to a different class or offline. So in the two scenarios you described, the outright or the say Amazon or Google hourly, or depending on what your baseline is. For where do you think offerings like managed bare metal by a provider or say VMware, where does that fit into the spectrum? And again, if it's inappropriate, we can push it off to some other time. I think
the point you're mentioning is this aspect of, there is a spectrum here. On one end you own everything, right? You have your own data center, and on the other extreme you're using a public cloud. There are a variety of things in between, and let's try to enumerate them. So on the spectrum of things that people deal with, enterprises deal with, you have public cloud on one end and data center on the other extreme. The intermediate thing that Ted is bringing up is this aspect of, say, Equinix or IO.com or other co-location facilities that will provide you So the co-location companies in between. Then we have another example that I think we are just about to cover, which is called a private cloud. And I would put this private cloud somewhere in the spectrum also. And then this other aspect of somewhere in between these two is the aspect of hybrid cloud. And that is a range of possibility where we can mix and match as to, at the end, what we are really doing essentially is there is this customer, and it is our company that is servicing that customer in form of a service that we want to provide. And that service you can provide through using any of these solution sets. And so that's the backbone that is available to us so that we can provide some form of software as a service to our customers, who essentially end up, generating revenue for the company that we work for or we create. And there are these plethora of choices available to us. Now, yes, go ahead.
I have a follow-up question, Ted. So are you talking about like a dedicated hosting solution where you hit an infrastructure that's dedicated to a single customer that's in an outsourced facility, or an in-source type of arrangement where you have the hardware sitting on your data center floor but managed by a third party?
No, it's where the provider, I guess it could be that, but I guess I was coming more along the lines of, say, something like, say, an Internet or a CenturyLink, who might have a bare metal offering, who manages the hardware, dedicates it to you, and manages the hardware, maybe even the hypervisor, or has a VMware-based solution where you're putting those 30 servers at 4 meg RAM each on VMware. So maybe that's more of an offline question, but I think I'm getting my question answered here, in that there's a large spectrum, and any and all, either specific choices here or combinations thereof will have an optimal cost based on what the earlier question that was asked by one of our co-students. Whatever your baseline is and your predicted growth, there's got to be a combination of these, and I think unless you're hitting it, that's going to give me the right combination. So that's...
There's a lot of argument in the industry right now as to which one of these is cheaper.
Yeah, and I think cheaper is a very, very subjective question, because it depends on the company, right? You have this company, they might have some data center already. And so there is this sunk cost, they have the equipment already, why not use that? And then they might have people that are needed to make sure that the data center keeps up and running. So you have this additional people cost. And that people cost, whenever people are involved, it's all, variable. It varies from company to company. And so when you want to truly calculate, what is my return on investment of a new product I want to go, versus, if I'm actually not making any upfront investment and purely going public cloud, there is nothing upfront. All I go is pay as you go, just consume based on whatever my demand is. And that's a different model. So on the entire spectrum, the economics actually really depends on a company that is at the target of discussion. And so it essentially boils down to a spreadsheet that applies to that organization. Is it worthwhile for them to set up your own private cloud? So we have a couple of Boeing folks here at this in this. And so what Boeing is essentially doing is evaluating whether they should continue to have a data center or go all the way to the extreme on the other end, where we will have a public cloud usage inside the company. But on the other hand, they have another situation where Boeing is also debating, should we allow our infrastructure, our data, our core key assets in terms of applications, should that be allowed on a public cloud, or should we keep that internal? And so at this moment, Boeing is actually experimenting with OpenStack, which is an open source product and allows us to create a cloud for ourselves. And that is a classic implementation of a private cloud. And how is private cloud different from a data center? That's probably a subsequent question that you might have. How is a private cloud that is all inside my firewall in the Boeing company, as an example, or in the Expedia? We have some Expedia people also in here. So in the Expedia company here, the idea is, should we put all our applications here on the cloud? And when we say private cloud, what does that mean? And so that is something, I think it's a logical next step in our discussion in terms of the service models we have defined here in that same definition. They define these three service models, which are probably fairly intuitive, and I think most of you know that already, but just correct me if I'm wrong. One of them is delivering software as a service, and the other one is platform as a service, and the third one is infrastructure as a service. And I will go through them, in just a moment. But I want to actually discuss these things, the deployment models first, before I will come back to the aspect of service models. So SaaS, PaaS, and IaaS, we'll discuss that momentarily. Just stand by for that. I want to discuss this first, which is the distinction between private cloud and public cloud and a hybrid cloud, and a combination of some of that is they have defined here in the community cloud. And the key definition here described that they have described here essentially is, let me go one by one in articulating my thoughts on what they have here. So back in our notepad here, let us go deal with them one by one. So we were discussing the spectrum of possibilities. So when you have a data center, you basically have your building, your heating, cooling, your equipment, your software that will run on the data center, and you basically are managing your networking, your connectivity, your temperature of the building, the airflow, and the whole thing, and repairs, maintenance. You need everything to maintain and manage yourself, and that is the data center. And the distinction between this versus the other one is a private cloud, where you will have the same thing. You will have your own building, your own data center, almost like a data center, except in here, you will deploy the model of deployment of your infrastructure will be subtly different. It will actually follow these principles, these ones that we discussed early on, which is, even when within your company, you will provide on-demand self-service access. What does that mean? Even within your company, so let's say the example of OpenStack as an application, which is going to be deployed on a bunch of machines, but all in-house. So it is going to be in-house, and that is how you will build up a private cloud, PRIVATE, private cloud, and you will build that up just like a data center would, except you will include this software which brings the capability of on-demand self-service. What does that mean? It means that internal employees of your company can actually go to an internal website and pretty much like what you saw in the example of Google or DigitalOcean or Amazon, just on-demand access your resources as and when you need something internally, as opposed to something like you request an internal ordering system to get a machine created, and that takes time. When you want to order something in classic old data center, I need 30 machines dedicated to my application, would you please do that? And somebody will request an application, and then eventually it will be processed through an approval process, and all of that can be automated through a deployment of what is conceptually called a private cloud. And that's what OpenStack-like software enables. OpenStack, as you probably know, is an open source software that is built on the concept. Let's talk about OpenStack also a little bit. So OpenStack here has all the capabilities that you will see from a large-scale cloud computing provider application. And here you have the compute capabilities, storage capabilities, networking capabilities, centralized dashboard, sharing of services, on-demand access to any of these resources, and all done internal to a company. So you can basically centrally monitor, manage, operate, and have your internal employees request resource just like they would in the context of a public cloud, just like that, except all of that is sitting inside your data center, inside your firewall. So you still retain the overall control that you need to retain for security or for other business reasons you might have. But at the same time, get the economic benefit of cloud computing across your company, even though you might spend upfront money in terms of making sure that you are going to spend some money upfront in making your private cloud up and running. You will have that. But the other aspects of making sure that these characteristics are met, meaning on-demand self-service for your internal employees who are your internal customers will be able to consume and order and release and relinquish, get rapid elasticity, meaning you will give them a machine as soon as they will call through an API, or give you a machine, give them a machine whenever they will visit an internal dashboard and provision a machine. You will share that resources internally within your company, so that, say, marketing department in Boeing versus customer service in Boeing, or other companies, other divisions of inside Boeing who need machines, who needs applications for their internal applications or for external customer facing applications, when they need resources, when they want to grow and shrink, they can all do that internally using the capability that tools like OpenStack provide, but at the same time reducing your management overhead in terms of what you would otherwise do in a classic data center. So you will conceptually build something like this company is actually the creator of OpenStack, Rackspace. You have heard of this name. This company created a part of OpenStack software, and another organization developed NASA developed the other part of OpenStack. So NASA and Rackspace together, these guys built this product that has now become really big. And it enables conceptually very, very similar to what you get here in Amazon. Conceptually, not programmatically, but conceptually very, very similar. And you get all the economic benefits that you would expect to see from a large public cloud provider. You can get the same economic benefits inside your company if you are able to deploy something like OpenStack on your own hardware internal to your company, and keeping all of that in your control, in your private domain, inside your firewall, and still enjoying all of these benefits which are enumerated here, including the aspect of measured service. And you might ask what is going to be measured and who's going to be paying for it. And this is basically internal economics. So you have, like internal funny money. So you heard the name funny money before, did you? Where you take money from one pocket and put it in the other. This is called, yep. So if you know the word funny money, basically it's internal money where you allocate budgets and you pay the other company. So, a marketing department can pay the IT department for a resource that they will be using. And so that's how accounting is taken care of. And internal resource providers will be able to get paid at an internally negotiated rate based on what they're discussing here. So the measured service comes into play. You have sharing of resources, you have network access within the company, elasticity, you can grow and shrink. And that's another benefit that you probably know already by now, which is even if it is in-house, even if it is all private to you, sometimes if you spend a certain amount of money up front and your marketing department might need something at this moment, at a new launch, they want to get some more resources, whereas your service department may not need that much resource at that time. But once marketing successfully markets it and people start using, then they might actually need to change this model, and that model might become different in that it might become something like marketing needs may go down, but the service needs might grow up. And you are at the Uber level, at the company level, at the organizational level, are able to adjust without additional expenditure. The sum of this and this is roughly compensated across different organizations within your company based on the demand of their resources might get compensated. So you may actually service both the service organization as well as the marketing organization with a set of resources that is not the maximum need each one of them needs. So this might need, say, a unit of, say, 100 versus only 20. And this is just figurative numbers I'm saying here. And so you don't need to spend all of it upfront. You can, you don't need to have 100 for these guys and 100 for these guys. You can just figuratively put, say, 150 and still have some reserve capacity left for any kind of deployment, say, that is still left over. So you still have some reserve of 30. I'm just figuratively saying these numbers, but the idea is you still end up saving some amount of money, and you don't have to address their peak capacity needs. from the marketing division versus services division that you might have in your company. And so that's how companies tend to optimize in terms of being internal service providers to internal customer organizations from within the company, at the same time gaining economic benefits of what cloud provides. And that's the concept that I wanted to discuss in the idea of deployment model of a private cloud. A public cloud, you probably know by now, is super clear, is that you have public companies such as Amazon, Microsoft, Google, Rackspace, HP.com, Cisco Cloud, IBM Cloud, you name it. There are so many cloud providers. Each one of them essentially is doing this idea, which is they will have certain regions. So in the aspect of, let's look at this company called Google. So here is Google. And in Google, yes.
Quick question. Do you know if with OpenStack they have the ability to add automation inside the VM that they create, or whatever they call it?
Correct.
Yes. I know you can just spin it up, but can you do stuff inside that VM or instance or whatever they call it? So let's say if you need to install a software when you deploy that VM, that let's say that it is Ubuntu, can you, like on the Amazon, that you can just say add all these packages after the fact and configure all this? Can you do that also with OpenStack on your local?
Yes, sir. Yes, sir. You can. Was that Carlos speaking?
Yeah.
Okay. So yes, sir, you can. And in fact, that aspect of configuring inside a machine once it is created. So creating a machine is kind of boring. Honestly, yeah, you got a machine. Now what? Unless there is something meaningful, something useful that you can deploy on top of the machine to make it productive, to make it useful, to make it usable by the customer, by the end user. And so, yes, you can create resources and you can deploy resources, but what's the point? The point essentially at the end is that you need to have that customer, this guy, and your company is serving them, and they need to make use of your service. So you provide some service to them. It is typically software as a service, by the way, software as a service. And you might have other things also, but this is the most dominant thing. So you're providing some service to your customer, and they're going to pay you money. Like this money flow has to happen. And this cannot happen by just creating an instance, right? And so you create an instance in the Amazon cloud or Google cloud or Rackspace cloud or OpenStack cloud. That is not interesting. It's pretty darn boring, I should say. If the instances do nothing, I mean, they just exist and then do what? Nothing. So you have to configure it. And that configuration is in fact, that is what this the second segment we have in our program, which is the DevOps segment, is exactly focused on that idea, which is how do you take a machine and configure it to run an application on top. And we will actually include some of this in this section also, in our technology section. We'll actually do some of these things pretty quickly. But configuration is possible, yes, and it is absolutely required in everywhere, wherever you get a machine. Without configuration, you will not be able to run an app. And if you're not running an application, you will not be able to provide a service. You need to be able to provide services to your customers because they are the king. They decide what you get. And so you want to get that revenue, you better serve them. That's the only way to succeed in business. Especially, actually in any business, you have to serve your customers to get paid. That's the only way to success. And so that is what is important. And yes, you bring in a very good point. And OpenStack by itself does not give you a configuration tool, but you can use a bunch of them. So like Chef and Ansible and Puppet and Babushka.
So the answer is no.
The tool itself, OpenStack tool itself, does not give you that. No.
Okay.
No, it does not. So you have the if you look at this compute, this particular section of that software called OpenStack Compute, all it does is provision and manage virtual machines. That's all it does.
So another thing that seems to be missing from on the OpenStack is just like services in general, like app queuing services and things like that. Is that something else that's genuinely missing from OpenStack, or is it just not obvious?
I would say that it is missing from everywhere because service is in another layer. So, what you just mentioned is you mentioned a queuing service, right?
I don't mean services as in like professional services. Queuing, like for example,
Yeah.
on Amazon, it's message bus, or I'm sorry, on Azure, it's message bus. On Amazon, it's a simple queue service
Mhm. So,
that are part of the PaaS layer.
yes, you're right. And so these aspect of simple queue service essentially is a additional service on top of what Amazon already provides. Let's go look at that. Here, Amazon dashboard. What do you see here is the Elastic Compute Cloud. And this is the bigger dashboard, which is bigger than Elastic Compute Cloud. So if you go look at the upper left corner, that's where you will find Elastic Compute Cloud. And I'm going to zoom it a little bit. And so in this section, you have this portion here, which is, let me see if I can highlight the mouse better. And so you have in this where did it go? Here. So EC2 container, Beanstalk, Lambda, these guys, the four of them on the upper left corner are the compute equivalents. And everything else are additional services that Amazon has provided to us, but they are not a part of the compute scenario. There is
Right.
this segment below called the storage components, and these are the storage related things. Then there are databases, so there are database services available. Then there is networking, and then they provide you networking capabilities. And so one of these guys is actually the queuing service, where is this one here. And so these are additional services available to customers of Amazon beyond what Amazon does from a core compute perspective, which is here. And so if you look at OpenStack, they don't have it because what OpenStack essentially broadly translates to is the compute section and the storage section and the networking section. That's what the three core resources that we discussed earlier.
It doesn't even have all of those. I mean, like this.
No,
It
no,
doesn't
no,
even.
no,
Yeah.
no.
So I guess so what one of the things that we're trying to do is to take the infrastructure as a service, which is basically what you're describing right here, and because that's really where OpenStack limits out. And find ways to add those developer resources, which seem to be driving shadow IT initiatives where the developers leave for those other services. And if you build an IaaS offering in order to bring them back, you're still not going to be hitting the marks because their apps aren't going to run.
That is correct. And that's where you need to further take that next level. So, from a resource perspective, shadow IT comes in the place where you have your internal processes that you have to get a set of machines doesn't work. So people spend their own internal budgetary money on some infrastructure and get their own side gig going on within the company, and that's what some people call shadow IT. And so it's a variety of names to it. But the bottom line is you become your own IT because your corporate IT sucks. Let's put it that way. Brutally speaking. So the idea is those guys don't help us, so let us build our own. And then you have the infrastructure, but now what? And that's where the end-to-end automation comes into play, where you have to take that next logical step. Is now, yes, you have the infrastructure ready, but that doesn't do anything, right? You have to configure it. You have to completely make sure that these machines that you have run some application, and not just some application, but the one that your customer wants. And then you have to make sure that this application gets delivered to your customers. And that delivery essentially has to be in a fashion that is very critical. They will give you feedback. Customers will give you feedback. Hey, change this, change that, and that feedback is constant, and that keeps coming. And so you gather that feedback, and you will accumulate that and change the application itself, and you will keep sending an updated application over. And that is the model that people are running. So if you look at any example today, let's say the Office 365. Let's look at this application. It used to be the desktop boxed product that we used to have. Just a few years ago, you go to Staples, you go to Office Depot, and you buy a $550 shrink wrap box called the Office from Microsoft. Today, the pricing is completely different, radically different. What has changed dramatically is that now this is a software as a service. This is not your regular Office. If you go look at business or home, in both situations, what do you see? the pricing is on a per month basis. That's a change, fundamental change here. So you have a per month pricing. That's one change. The other change that has happened is that you can actually use Office online, which is something like, let's say, Word online. And so you can actually consume Microsoft Word online just like that by visiting a browser. And you can create a new document. And this is, by the way, my Office 365 account. And you can create, without installing anything, use Microsoft Word online in a browser just like this. And you can share, collaborate, do everything that you would expect it to do otherwise. But this is a service, not a software. It is running in Safari browser, by the way, right now. As you can see, I'm running Safari. And this Word application is a service that Microsoft is now providing to us because we are subscribers to this product and we are able to consume that service. And that is a fundamental shift in the way business is changing, is that people are creating from their box product that they used to have, software, they're converting that over into a SaaS model. And you see every major company in the industry today is transitioning just like this. So this, I call it, I have a word for it, I call it SaaSification. And this is what is happening. And this is basically happening because people are demanding, I need to pay you some dollar per month or some dollar per year, as opposed to something upfront, a huge amount of money upfront. And then, I wait for the next cycle to update. And that agility is what is expected of us. And that agility comes from the fact that customers are willing to pay a little bit every month, but they are going to give you feedback. So this, based on the feedback that you gather, you want to actually take your application, improve upon it, and keep developing it, keep incrementally updating, and not only that, deploying it online for your customers right away, so that the customers get the benefit of their idea, their feedback request that they are sending you, and you're able to take all that based on a resource that you accumulated. So the very foundation, you will have the infrastructure as a service at the basic, at the foundation of it. But at the end of it all, you need to service your customers, and they will give you feedback, and you will gather that and keep improving, keep iterating in this cycle.
Yeah. So I mean, this is the outside the company view, is the SaaSification as you described it. Mm-hmm. Isn't the internal view more PaaS?
So the internal view, in fact,
in other words, like for example, the only reason I bring this up is because it sounded like you've got Boeing and Xperia on the line, and then we also deal with IT. The IT department is actually their customer is the DevOps.
Yes, correct. So
in fact, the IT service would be PaaS, and the DevOps delivery is SaaS.
Yes, you can classify it that way. But let us, before we discuss that, I want to clarify a couple of things here and actually get some experience in terms of understanding what PaaS is from an outside perspective or from an inside perspective, what it can mean. And I will give you some things to do that you can actually figure these things out yourself, because we will use a PaaS ourselves. We will use SaaS. In fact, I just use SaaS for you. I created this Word document, right? And so we just use software as a service. It's trivially simple, not that big a rocket science at all. But SaaS is the easy part. Infrastructure is, a very necessary part that we need to do. But PaaS is kind of different from different perspectives. So let us understand and realize what does that mean in the context of this definition that we have from NIST. So let's go deeper in here. So the first thing in the 3 service models we have here is software as a service. And the idea is, conceptually, I just illustrated to you. You have an application, you have some software that you run it either locally or some server that runs it for you, for your customers, and the customer is able to consume the software itself. However, when you provide that same software, instead of running it on their computer, you run it via a web browser and are able to provide to your customers. So there are tons and tons of examples of SaaS that you may have heard of, and I can, give you. Why don't you give me examples? Like, give me examples of SaaS that you know. Just rattle off the names. I'll start opening some of them that I know of. So here is one of them: Salesforce.com. So here you can do customer relationship management from a sales funnel, sales pipeline perspective, understand this is a good one. Another one is Workday is another good software available as a service. It is a human resources ERP application if you see. There is Office that you just saw me use it. You probably know that. There is this thing called Google Apps for Work. Is another SaaS available to us from Google. So they are basically competing with Microsoft here. And you can set up, by the way, having said that, I should also tell you that each one of you, I'm going to give you an account on Google Apps for Cloud Genius. And the benefit of that is you will probably like it. So I'm going to show it to you instead of talking about it. The benefit is like this. So it says everyone at Cloud Genius can use unlimited storage. I don't know if Hitachi guys are interested because you already are a storage company. At least I treat you as a storage company, but this is available to you. If you like it, I will give it to you. This is going to get you unlimited storage on Google Drive because we are an institution. So Google has given it to us basically. Google has given to all the universities and academic institutions in the US unlimited storage on Google Drive for everybody in that organization, including the people who attend and study. And so that is the reason why I am able to give it. I will like you to chat with me in the Slack chat and just paste the login name you would prefer. And I will enable an account after the session and you will have it. So that's another storage as a service available to us. And it is free and it is unlimited and free because of the fact that this is a school. Now, having said that, this is another service available to us. And so that's the idea behind providing services to customers through the cloud. In this context, Google Apps for Work is just one example. And so here are more examples. Having said that, let us also study the other aspect here, which is the infrastructure as a service. And if you look at this definition here, you will see that it basically boils down to getting your resources, that these three things: compute, storage, and network. These three things, you can make it available to users wherever they are. And they can on-demand access it, on-demand start using, stop using, release it, allocate it, and they need to pay for it, and they can consume it. And so that's the model where you get raw resources available to you, and that is another type of service where you're basically providing infrastructure, and it'll allow you to run whatever software you want, whatever applications you want, whatever OS you like, as long as the license permits. Which means that you cannot run Mac OS in the cloud unless it is an Apple labeled machine. And so having said, the idea here regarding infrastructure as a service is that you are indeed getting your customers to get use of these resources, 1, 2, and 3, on demand, self-service. And the model that we have here is there was a comment about preferred account for Google Unlimited Storage. It has to be the Cloud Genius domain. So all you can choose is the first part of the email address. I cannot give you on your domain. It has to be on Cloud Genius domain. That's a clarification. A couple of people chatted with me on that. So I can give you only for that. That's good. So having understood that it is the Cloud Genius domain, you can choose the login name, nothing more. Sorry. I cannot give it to you on your domain. Sorry. So with network, compute, and storage, these resources that you want, you can get them to your customers programmatically, just like a cloud provider would. And when you do that using OpenStack here, you can use this application to give compute resources. Similar to that, you can use this application called OpenStack Storage to give storage resources, and OpenStack Networking to give networking resources to your internal customers within the house, within the company. It's all mostly within the house, except if you're using HP Cloud, then they have used the same software on HP Cloud and made a public cloud out of it. So here, if you go log in, you will see that this is actually a public cloud offering based on OpenStack. So what you're looking at is actually OpenStack interface, and what it is giving us is the ability to create a compute services, monitoring, storage services, and they have recently started some database services also. But these are not part of OpenStack. The core OpenStack product gives you access to these things that are listed on the website itself. And so that's what essentially is an infrastructure as a service. When you're giving access to raw hardware resources, all again programmatically through an API call or through a dashboard. Now let us discuss the last one, which is the platform as a service. What does that mean? And so let us clarify that. PaaS, what it is doing to my customers, essentially. So let's look at who the customer is here in the case of PaaS. So I will try to draw a picture here, and I will try to illustrate the bottom-up drawing. So at the very bottom, you have to have some hardware. It has to exist. And when this hardware exists, you can then take that hardware and allocate that in form of some kind of an infrastructure as a service. And so you're basically now giving access to compute, storage, and network resources. And on top of this network storage and compute resources that you allocate through infrastructure as a service, what your customers will like to do, and who the customer is essentially at this moment. At this moment, the customer is somebody who's going to provide a PaaS to somebody else. And so the people who are consuming and creating a platform for other people, like developers, they will like to have a platform ready so they can just deploy the application. So that layer is this PaaS layer. And this PaaS layer needs the underlying resource, these guys. And so the people who are essentially developing a PaaS are infrastructure consumers. So they are consuming infrastructure as a service, and so the money essentially is going down. So the money goes down from developer to some service provider who's providing a PaaS service. And that service provider can be your internal IT organization, if you will, and they in turn will pay somebody to get the infrastructure layer. So this money again flows down this way. And these developers will create their applications, and that application gets deployed on top of the platform itself. And so the value goes this way. And so your ultimate value, you provide value to your customers, which is a service provider who provides the PaaS service, and they provide value to the developer because the developers are actually using the PaaS as a service for them, and they are creating an application, and they give that application to the customer, the end user. So the end user receives value in a chain, so that the chain begins at the very bottom, hardware. Then you have some kind of an infrastructure as a service layer on which you have some platform available as a service. And that platform is what is consumed by a developer. And then these developers will then take that platform, put their application on top, and then make that application available to the end user. So the end user ends up paying them. So the money flows down like this from the end user to the developer to the service provider to the IaaS layer to the hardware vendors eventually. And so an example of the same thing would be something like, you have these companies in Taiwan, such as, Compal or Quanta or Flextronics. These guys are making silicon, right? Flextronics. They make silicon. They make the underlying things. Even Intel and AMD. These guys are making the silicon. And there are many more companies I'm missing out. You can include Hitachi here, actually, that makes storage. So HDS as an example, EMC, VMware. So all these companies are basically providing your underlying hardware that is needed to make those services available. And on top, you will have companies that will make use of these underlying raw resources and create infrastructure as a service. and that service they will make it available to people up on top, and these people will be PaaS people. And what PaaS is and what does developers need, let's look at that perspective. That will clarify a whole lot, like what do devs need so that they can run the app, and what exactly can PaaS mean, and it varies from company to company, application to application. So the application essentially decides what is PaaS and which PaaS do I need. Is this guy decides what do they want from the underlying layer. What do I want here is what is decided by these guys, the devs. And the platform available as a service, sometimes there is a set of developers that actually write the PaaS itself. And the infrastructure as a service people basically provide an abstraction above on top of the actual hardware. So you have multiple companies providing a whole lot of things that eventually builds up infrastructure. Your Dell, HP put their label. Sometimes they make some hardware, but you have HP, Dell basically rebranding these other manufacturers what they make, and they will put their sticker on top and sell. That's what practically happens. And you can dispute that. Of course, it's a debatable point. If there was an HP or Dell employee, he will say, no, we don't do that. And I understand. And so having said that, the underlying hardware resources that are provided to the infrastructure as a service developer will basically provide your compute, storage, and network resources on demand to the PaaS people who are PaaS devs. And the app devs are different. They decide what PaaS they need, and they basically work very hand in hand. So the app dev and the PaaS devs are cooperating. Now let us look at an example application as to what that could be. And one of the most popular applications on the internet that is used today, if you look at many of the websites, it's a large number of people actually use this application called WordPress. Are you familiar with this thing?
Yeah.
Do you guys? So WordPress as an application is available as an open source, and so you can go to this site and download the app. It's available here. So it's a click and download. That's what the application is, and it's already built for us by open source community, and the community is backed by this company called Automattic. The guy who develops that company and who develops this WordPress application, his name is Matt. His website is ma.tt, and his company's name is Automattic. And so Automattic is a funny spelling, Automattic. And so that Automattic company creates a platform available as a WordPress.com. WordPress.com is the platform you can actually use. It's a service available to us, all of us. It's a free service that you can deploy your own WordPress for free. So that is the distinction between WordPress.com versus WordPress.org, is that this WordPress.com is a software as a service available mostly for free, almost. There are some aspects which are not free, but this product that is available in form of a zip file, that is totally free and open source. And that is predominantly used on the internet. Like this, there are many other applications that are also available that are very popular and open source. For example, Drupal, D-R-U-P-A-L. And this Drupal.org is another application available again in open source domain and is extremely popular also, Drupal. And that's the software you can get from here. You can download it somewhere with a link at the top somewhere here. And this agency called the White House uses Drupal. So this site, Obama's site, uses Drupal as the application, and the company that supports it is the creator of Drupal, and that guy's name is Boitart. I think his company name is Acquia. And so this company created whitehouse.gov for Obama and the previous presidents. They have been doing it for quite some time, and this Drupal software is created and sponsored by this company, but the software itself is open source. And so, looking at these two examples, let's see what the actual application itself, the Drupal application or the WordPress application, what do they have in common? What are the things that are required by the application developer and expected from the underlying platform as a service? So the developers of the platform will need to provide them some platform as a service to these guys. And this will run, say, WordPress. And so if you look at that WordPress application, and let us understand from the application developers, hey, what do you need from the past? And so let's ask that question here. And so here we can ask that question very simply by saying documentation, and say things needed to start WordPress. So frequently asked questions. So there should be a place to find system requirements, right? So system requirements for WordPress. And so the system requirements are here. So they just told you that we need PHP version 5.6 or higher, MySQL version 5.5 or higher. They just told you black and white, that's what we need. And so at the bottom line, you need to provide these things from the underlying platform so that the application will run. If you don't provide these things, the application will just not run. That's simple as that. And so these are the things that we need that platform as a service to provide. And so we will go back to this and expect that the PaaS will provide us PHP. And what was the other thing? MySQL. Yeah, MySQL. And also one more thing they mentioned here is Apache, the mod rewrite module. So you need that also, right? And so you need to get Apache also. And another module called mod rewrite. So we need to have these modules included with the Apache application server. You need to have a MySQL server, and you need to support PHP language. And those are the requirements. And so that platform that will run WordPress, that's what you need. Nothing else, nothing more. That's exactly what you need. And if you meet that, you can literally take that WordPress application, drop it on the PaaS, and have it running like this. By the way, this is also a WordPress application. And I do exactly what I just told you, is to use my own configuration methods to create a PaaS. In this context, I am the PaaS dev, and I am not the app dev because I'm using this app. And I have developed my own platform. And by the way, you will also develop your own platform to do exactly the same thing. And you can expand it, extend it also. The idea is you take some underlying resource, some infrastructure resource as a service, you consume that, and you put your PaaS on top. And then you take the app, load it up, and off we go. We have it up and running like this, or like this. So the same site, right? That is what is running right now, and it is running on the Amazon cloud right here. And this is the running instance right now. And you can actually match it up. So you have the IP address. The public IP is this. So it's 52, 25, 83, 187. Let us compare that with a terminal I'm opening up. And by the way, you will have access to terminal in your workstation. And I will go dig and find out the IP address. And there we go. It is the same IP address we have here. The command I typed was this. And you can type the same command in your console. So the question, there was a question in chat which was, isn't WordPress one of those strange technologies which can be considered both PaaS and SaaS? Yes, indeed, you're right, sir. And the answer, the clarification answer to that is that, in the exact sense of this word defined in your definition, if you read that language, Here, the platform as a service, exactly what they mean is that they want to create the capability for the consumer is to deploy onto infrastructure consumer created or acquired applications created using programming language, libraries, and services and tools supported by the provider, blah, blah. So you read the definition. The bottom line is, in my way of thinking, a platform, I've simplified it myself. So the idea that I think of is that anytime you put something on top of something, the underlying something becomes a platform. That's my simple definition. I know it's wrong, but that's how I tend to think. So you put something on top of something, the underlying thing is called the platform. And you can generally say that. And so that's what is happening in the industry is then people will say Windows is a platform. Now, is that really a platform? Yes and no. You can call it a platform because you can then set up Word application on Windows, right? And so that Windows becomes a platform. Yes, it is. Some people say that the App Store from Apple is a platform. Is that a platform? According to this definition, it is not. However, I might agree that anything you create your app and you put it on the App Store and that people can consume it, it's a platform. So that's a vague definition. Now, sometimes people will extend the same idea and say, WordPress, isn't that a platform? And I would say, yes, it can be, because you can extend WordPress. Extend WordPress by putting your extensions on top of WordPress, which in turn runs on some PaaS, which in turn runs on some infrastructure, which in turn runs on some real hardware. So anytime you're putting something on top, the underlying thing is the platform. So when you extend WordPress, WordPress becomes a platform. But that in turn requires some PaaS, and that PaaS requirement is very clear. It is MySQL, PHP, Apache. That's the requirement from the PaaS perspective. That's what WordPress requires. Now, to extend WordPress itself, what's the platform needed? You need WordPress. That's the PaaS. Now, you cannot call it PaaS unless you are providing it as a service, but in vague definitions, yes, you're right. The question was indeed valid, that it is strange that you can actually, anytime you can extend something, the underlying thing becomes a platform. And you can extend WordPress, for example, by creating plugins. So you can go here, wordpress.org, and plugins. And there are millions of plugins available here on this site. So in fact, all these plugins that are available are downloadable. How many plugins there are? Not millions, sorry. Not millions. There are millions of downloads, but there are 40,398 free plugins available. And these plugins extend the functionality of WordPress, and therefore you can call WordPress as the underlying platform on which these plugins are running. And that's a valid way of thinking about it. Having said, back to this site, where is that? Here? No, not this. Let me open it up again. You can see that in my example, I am running a bunch of extensions, and I will show them to you right now. It's coming up. And these are the extensions I have extended the plain WordPress itself with customization, with use of plugins. Some of them are free, some of them are not, some of them are customized, but I have some about 38 active plugins, 38 of them. So yes, I'm using WordPress as a platform on top, and these are the names of plugins that I'm using. And yes, over time I will walk you through exactly, and you can customize yourself and essentially understand what it means and expand it to build something that your customers want. And so a simple one for you to get a quick idea about, let's say, yeah, so those emails that you may have received, right? You may have, when you signed up on the join button, you must have received some automatic generated email saying welcome and this and that. So that thing is sent out through another plugin, and that is this Mandrill plugin, and that is the plugin itself that I'm using right now here. And what it does is it will send emails out to anybody. The site will send emails out. So essentially, it's a service. It is an extension of WordPress to allow us to use WordPress as the backbone. But in this context, the extension is to use SMTP protocol and use a method to send out email notifications. So when the application decides that I want to send an email to a user, it will use this extension and send an email out through SMTP and send that email to you. You may have seen emails like, those ones, like this, welcome to Cloud Genius, like this, so those emails are automated. They come out from a service. The services that I use is another software as a service. It's called Mandrill. And that is the plugin that you saw in action when you got this email, welcome to something, welcome to Cloud Genius. That email is automated, and you receive that primarily because of the plugin that was sent to you through this method. And so I'm going to show you that part also, so you are clear about it. And I'm going to show you that these messages are actually being sent out to you. So you have reports outbound, and you can see that these people are actually receiving emails. So you have this email went out today, and these are automated emails went out at this moment. You can view the content, and that's what the email that went out. And so that automation was possible through use of this plugin that extended the functionality, and that's why, yes, you're right, it can be considered as a platform. And by the way, that logic applies to anything and everything. Anytime you put something on top of something else, the underlying thing becomes a platform. That's how I tend to think about it. That's how the industry has used the word in general. In fact, if you go and look at your hardware itself, and I'll give you another example of EMC, which was my previous company, actually previous company, where we have a product called Symmetrix. And this Symmetrix product itself, actually, practically it's a bunch of disks. It's a bunch of disks configured as high-end architecture, and so you can make fancy names to it. But at the end of it, the underlying host operating system, you have Windows or Unix or mainframe, whatever you have, they will look at this EMC as a disk. And so we will internally inside Symmetrix, we have this platform and that platform at the hardware layer, because we are building modules after modules on top of each other as we design the underlying layer structure to create something that is highly available, resilient, fault tolerant, and high performing, and accessible to any of the host operating system, Windows or Linux or mainframe, any of these guys, through any kind of connectivity that they might have to our set of disks. So we used to use the word platform to attribute one of the aspect of this underlying box, and even the box was called a platform. So the platform name has been used in a very vague fashion, and that's one of the reasons why this institution NIST has clarified our definition for it by calling it out here. So you should take a careful read at that, and yes, we continue that discussion. So that was platform as a service from a perspective of WordPress. By the way, the same exact set of application sets are like we discussed, PHP and MySQL and Apache. And these three things are popularly clubbed with the underlying Linux operating system. And these things are called the LAMP, also called the LAMP stack. And this is the common word used to build out the underlying platform needed for us to be able to run some application like WordPress on top of this stack. And that is what you will see. So in the example that I'm just describing to you, this is a immensely popular stack, and people have modified it a little bit in the nomenclature. People have converted that name. They've replaced Linux. Instead of Linux, they're using Windows at times, so it becomes WAMP stack. And sometimes people will use the instead of Apache, the application Apache, they will tend to use another application called Nginx. Nginx, that's the name. It's a Russian open source, and the name then becomes L. Actually, for Nginx, they tend to use the word E, as in Nginx, so they call it the LEMP stack, LEMP. And so it has been modified. Sometimes people will replace the name M for MySQL. They will use MariaDB, Maria, and that is also the same acronym. And PHP, sometimes they'll replace that name to Perl and Python, and they will also come up with their own acronyms for whatever the platform they want to use. And it's really depends on the underlying application that you want to run and what that application requires. So it is the app dev that dictates what do I want from the PaaS, and that is what the PaaS dev will create. And the PaaS dev will dictate what infrastructure I want, and they will dictate what infrastructure is made available to the platform as a service dev. And these guys will then dictate what hardware I want, and they will appropriately buy hardware, rent hardware, go to a colo facility, build their own private cloud, public cloud, the whole spectrum of things you want. The entire spectrum we discussed, from data center on one end and public cloud on the other. So the entire spectrum belongs here, where the infrastructure as a service developer will decide what they need to have from the underlying hardware layer, so that they can service their platform as a service developers, who in turn will service their application developers, who in turn will actually develop the application and deploy it for the customer. And that person or entity will then provide you the money and feedback. And through that feedback that you collect, that you are able to iterate. And so that iteration happens at multiple levels. You can iterate on between customer and the application itself. That level of iteration happens. You can iterate further again on this layer, which is application developers and the platform developers. Sometimes they can be a part of the same company. Sometimes they're not. So it depends on the application itself. Sometimes, say for example, Netflix, the application that you see when you go to hold on, I think I accidentally opened a new page, but when you go to netflix.com, this application that runs on the browser, or you can download it on any of the devices that you have. So basically that application that you see, watch it on your TV. So TV is giving you the app on the go. So iPhone, iPad, Android, so you have your app store itself. You can probably have the application here, Netflix. Is it here? I don't watch Netflix, so sorry. There should be a Netflix app, maybe not on this app store, but the other app store, iTunes app store. They will have a Netflix app somewhere here. Yeah, so there it is. So Netflix app you can download, and this app is built by Netflix and put on the, it is created by Netflix Inc. And it is available for you to download from the iTunes App Store. However, this is not the entirety of the application. This is the client end of the application. And that brings us to the other topic. So before I switch topics, what I want to ask you is there any question on this aspect of discussing here, which is the aspect of essential characteristics, your service models. There are three: infrastructure, platform, and software. And then there are deployment models, which is public cloud, private cloud, hybrid cloud. And the definition, I think there is some trend in the industry where they're mixing and matching the use of word hybrid to mean anything. And in this definition, it is it is called out as composition of two or more distinct cloud infrastructure providers that remain unique entities but are bound by standardized technology. And so that's their definition. But the industry has modified it a little bit to the extent that I would say that it is something like this. So when you look at the hybrid definition. Hybrid can mean, one infrastructure provider, number one, infrastructure as a service provider, number two, and you mix them. That can also be hybrid. Sometimes people will define hybrid differently. They will say that, we can make a hybrid out of our own data center running internally and the public cloud. And you can call that as a hybrid also. And so mix and match these two, mix and match one infrastructure provider with another infrastructure provider, provided it's a similar technology, and also technology compatibility is needed here. Sometimes people will mix private cloud and public cloud together, and that can also be a hybrid. So the definition is evolving a little bit, and so people use that word differently in many places. So that was the hybrid concept. The other was community cloud, and this is a definition that they have basically limited the set of people who can use. So it is essentially in the concept of a public cloud, except that the definition of the public domain has been limited to only a community. So this is the public domain, and this is the community. So when you limit it to a particular people, community, if I can spell it right, yes. So it is limited to a community cloud, then that becomes the user base for that cloud, and that's how their definition of community cloud is. And so that's the 4 deployment models, 3 service models, and 5 key characteristics of cloud computing. So having said that, are there any questions on this topic? I'm assuming there is no question. That must have been super clear, I guess. Okay, then I'm assuming there's no question, and let's move on to the next topic, which is the idea that I was about to begin discussing, is this idea of an application. So when you download this app, and you need to, of course, give your login name, and it will download the application and install it on your iPad or iPhone or something like that here. But if you visit that site, which is going to be your Netflix site, for example, this site can use a bunch of technologies. So when you sign in here, you can see that the application itself gets loaded onto your browser and gets to run it right here. What does that mean? Is that we have a bunch of different things going on right now. So let's look at that from a clear perspective. So you have the end user, and that person has the app that they are looking at. And so this Netflix app can run on a bunch of different platforms, Xbox, your iPhones, and actually it runs on browser also, just a Safari browser or a Chrome browser, or just any browser. So if it is running on IE, it will use some kind of a technology called Silverlight. If it is using Chrome, it might use a technology called Flash. If it is using Safari and you do not have Flash enabled, it will use HTML5. And so variety of technologies available in the browser space will have that particular client-side application. So this is the client user, the user who's the customer, who is watching House of Cards. I'm just saying that. But that's the application that the user is using, is binge watching House of Cards. That's what's going on. Now, on the other end, this application is actually hitting some IP address somewhere that Netflix decides where it hits. And that is where the application actually runs. This is what I call the cloud application of Netflix. And what Netflix has done is develop their own platform. So they have their own PaaS, internal PaaS. And this is developed by Netflix. And this application also is by Netflix. And they happen to be using the infrastructure as a service provided by Amazon Web Services. And that's the clear scenario, as I understand from Netflix, is what they are doing right now. So when you look at the application itself, they are meeting the requirements of the application by creating a platform of their own, built by themselves. and they just run it on this cloud. That's the scenario. Now, if you look at the same concept, but in a context of a different application, very, very trivially simple. If you want to create your own WordPress solution, what you need to be able to do is get the application from the app dev. And the app dev here essentially is the open source. Open source community will give you that application. You need to take that application, you need to understand their requirements, and you need to develop some platform. And so you need to understand that you need to provide them this idea of a LAMP stack. Linux, Apache, PHP, and MySQL. So the Linux part is not a requirement, but it is the most dominant used OS that you will see. People don't tend to use WAMP too much because it is better and probably cheaper to use LAMP. And so they use the Linux application, Linux OS at the bottom, and provide these characteristics in their platform. And that's what they will end up using from an infrastructure as a service provider perspective, and get a Linux box and configure these things to use Apache, MySQL, PHP. And in certain cases, when you want to expand it and make it a little bit more interesting and scalable, you want to actually remove this element also. And you want to just make sure that you're providing these things and are keeping a separate set of services, such as the MySQL part goes away and becomes a database as a service. And that is a scenario that is more common in larger deployments when you don't provide that thing on your own underlying hardware, but instead you get a different service and give that service available from a DAS provider, database as a service. And you can see that example here in the example that I would like to show you is, so yeah, here is HP Cloud, and here you can see that they have the relational DB MySQL available, and I can click this button and get a database set up for me. Right now I have nothing in HP Cloud, but I can create an instance containing a database. So it's a database instance that I will create. So I'll launch an instance, and this will basically configure a MySQL machine for me. So I can call it my database box. I can size it appropriately, size small, medium, large, whatever I want, and how much disk I want, what MySQL version I want. The only choice is 5.5, which is fine. And then I can initialize it with a specific set of database that I have to seed it to begin with, set up an admin user, or I can call it my admin user, set a password if I like, and then launch it. When I launch it, I get a ready-made database as a service available to me. So this essentially is a trade-off. You're basically trading off. You can put your MySQL right here, but instead you chose to outsource it and to some other company who's going to give you database as a service. And that is a decision you need to make from a platform perspective as to what do you want for your customer, who's going to be the application that is going to consume your platform. So either you decide to roll your own MySQL on top of your own Linux, on top of your Amazon Web Services or HP Cloud or your own box or OpenStack or whatever else, it doesn't matter. But you need to have some box running this, and then you have to maintain it. You have to make sure that it keeps running up and running all the time. And so you can do it that way. Or alternatively, you can use a database as a service. This was D, database as a service. And so in the context of, let's say, EC2, Amazon, you can go scroll down, and they have a full section dedicated to databases here, and you can select RDS. And in this example, what you can potentially do is start a database box, and you can deploy MySQL right there. There are many other choices. In fact, they have this new choice which is compatible to MySQL. It's supposed to be very high performing, but this is their own implementation. They call it Aurora. This is binary compatible with MySQL, and that choice is available. But we'll just stick to MySQL, for example, and select that, and then say next steps, and then I can select my license, and I can select my DB engine if I like, whatever version of MySQL I want. Then I select my size that I want, bunch of different sizes. Then I want to select it in a multiple AZ, multiple availability zone, yes or no. I can decide that. I can decide what type of hard disk I want, magnetic or SSD or special purpose SSD. I can talk more about it later. And then you select the size, and then provision some IOPS you want, assign your database identifier, username and password, and off we go. So that's how you can configure. But then these guys will give you a bill. Either you maintain it yourself, or you pay them money and give this MySQL as a service. These are the choices available to us. So you can outsource it to a DAS or run it yourself, in this example, all the way ground up from IaaS and build it up. So those two choices at least are available. And the application would expect a handle to connect to either the service MySQL or your MySQL, one of these two. It will expect that. And so you have to provide that MySQL handle to the app in one of those two fashions. You also need to provide a platform where they can run the PHP language and serve the web pages through Apache Web Server. And then you can have your application running, and it will go live. And that's the trade-off you need to be able to do from a application perspective when you're looking at an end-to-end scenario. So back to our discussion on what this was. So if you look at this Word Online, you probably saw me do that early on. And so here we create a new document and then create a Word document like this, and I can make the font go bigger like that. And so what you're looking at right now, there is nothing installed locally, but there is an application running. So what is going on? Let us understand that. And that topic that we are discussing right now is, I will call it a web application versus native application. So I will distinguish the two very clearly. So in the native application, you're probably very familiar. It looks like this. Microsoft Word starts up. And this is running your native application right now on your blank document, create, and it starts. And there we have it. We are going to call it, I wrote this in the native Word app. And that's what I'm going to save it right now. And I'm going to make this a little bigger so you can see properly. And so here, that is my Word document. And I wrote this in the native Word application. I'm going to save it. And I'm going to save this in my OneDrive. So here is my OneDrive. And I'm going to save it hello.docx. That's the name I'm choosing, and I'm putting it in my OneDrive and save. And so it's going and it's saved. I can see the same exact document showing up in my OneDrive online version, and I can edit it. So I can see the same file. Where is that? Recent. And so this should show up right here in my browser. Hello, Cloud Genius. There we go. And it's the same document that opens up this time in the browser. And I can here modify it to say that I wrote this in the web application. Right now it is not in the edit mode. So I'm going to turn the edit button. I can edit it in two ways. One is to edit in Microsoft Word, so it will invoke the local application natively installed. The other one is to edit in Word Online. Now this is the second option. That is what I'm going to choose this time because I already edited in the full version with the native application already. So this time I'm going to edit in Word Online by clicking the second button. And here it is starting up Word Online, and I'm going to modify this. And here I'm going to say in the web app for Word. And I'm going to save that. And it saves automatically in your OneDrive. And what we just looking at right now, if you study that carefully and right click on the browser page, okay, they have disabled right click apparently. So the bottom line is I think we should be able to find out the code for it. So I'm trying to see if I can show you the HTML, CSS client-side code inside this application. So that's what I'm trying to see if I can enable that. Yeah, so here's the code that shows up. And this is the application code written in HTML, CSS, and JavaScript. They have created the Word application, which is this application, basically, the Word application using HTML, CSS, and JavaScript. The same idea is implemented in form of a native application, and this is not CSS, HTML, JavaScript. This is written in native Objective-C. And so it is, by the way, telling me right here that I have an update available, because when I wrote it in the native document, I have an update from the web document, so I can just update it, and updates available. And so I'll say okay, and so here are the changes showed up. And this is basically synchronizing between what I have in the native application versus the web application. And the difference between the two is that the implementation is completely different. The idea is the same, but this implementation of the web application is actually running inside the Safari browser right now. And it is written just like here, what you see. And this is making API calls. It's a very long application. I cannot expand the whole thing for you because it becomes really unwieldy. But you can do it yourself by right-clicking on the Word Online application and see it for yourself, the underlying code that is written on the client side. What you cannot see is the code written for the native app because it is written in Objective-C. Or sometimes if you're using Windows, it is written in C#. And that is how they are written and compiled and are available to you in form of word.exe in case of Windows. That's what you see here. Whereas Word Online web app is written in HTML. Why cannot I not type properly? And so HTML. I cannot really write properly, huh? HTML, CSS, and JavaScript. And these three together constitute this application, which you saw. And these two are conceptually doing the same thing, but written very, very differently. This thing needs installation. This thing does not need installation, but they're functionally similar. This is actually rendered, this application written in HTML, CSS, and JavaScript is rendered inside your browser. If you quit your browser, the web app goes away. If you quit your Word application, the Word application goes away. That's the subtlety of difference. But on the back end, what they are essentially doing is enabling the same exact experience. In fact, the page you see on Word is bit by bit identical bit by bit, as in pixel by pixel identical between the web app and the native app. So whatever font you choose, whatever location you have, by pixel, it is exactly accurate. In fact, the one of the tests that Microsoft has is to actually print a result of a document between a web application and a native application, and see it on a piece of illuminated glass and see if that exactly matches item by item or not. And that test has been expanded now to include other native apps. So this was an old test on Windows platform. Now they have expanded the same testing on iPad, Mac, Android, and all the other tablets that runs Word as an application in native form. Compare that with the web application that runs on the iPad browser, the Mac browser, the Android Chrome browser, and Windows OS in the browsers in IE and in other. They have this new thing. What do you call this thing? New browser from Microsoft. I'm forgetting its name. It just came out in Windows 10. Even that browser is tested the same way. And
Microsoft Edge.
Sorry, what was the name?
Microsoft Edge.
Yeah, Edge. Yes, yeah, Edge browser. So this Windows is actually starting. So I'm starting up Windows. I don't need to, but I just did. So what is essentially going on is that doing a pixel by pixel comparison on the result that gets created using a web-based application on each of these platforms with a native application on each of these platforms, and making sure that the paper print looks exactly identical. And that's the way they're testing it. And that's what makes Office applications a little bit more interesting than the other ones, which is it is cross-platform and just available everywhere you like it to be. And so having said, this is not new. It's not really new. The first time ever somebody's done it. Companies like Google has done it already before Microsoft did. By the way, if you look at the same thing, like for example, go to google.com, and in there you will find that you can create a come on new. And so here you can say new. Where am I? Okay, let me use the Chrome browser. Apparently it's not behaving properly. And so here Chrome compose, not compose email, close. I need to go to Drive. And you can see the same structure, which is going to show up here. I'm going to create a new document. And so say Google Doc, new. And you can see the same idea here. I'm going to create a new application, new document, and make it a little bit bigger. And then I will save it or download it. Whatever I feel like, I can do it. And if you look at this scene, this browser window, and right click on it, and look at okay, they're again hiding the code, but let me expose the code for you. Hold on. Yeah, they tend to hide the code that they want to show, but we can always see it from another way. There we go. So this is the code that you will see. Again, very similar: HTML, CSS, and JavaScript. Using those languages and tools, they have created Google Docs as a place to collaboratively edit Word document style documents that you can see here. And apparently they're running into some errors. But yeah, leave them alone. The application works. And the idea essentially is you can develop your client-facing applications in two fashions: a web application or a native application. If you're developing native, you need to compile it and load it up, either using a programming language such as Swift or Objective-C or C# or C or any other languages available on the Windows platform, and compile it, build it up, and then have the customer load it up. And then it works. Similar to that, you can create your iPhone applications, and you can probably have Word on iPhone. You can also have Google Docs on iPhone. You can probably see docs.google.com, the app itself. And this thing can show up in your iPad, in your Nexus phone, or in your Android tablets. The same application is natively available. So let's say Google Docs app, Android. And so this is the app that is available to you, and you can download it from the App Store. For it's not called App Store. What is it called? Google Play Store. Google Play Store has this Google Docs app. You can just install it. If you happen to have an Android tablet, you can load it up, and that is a application written native for your machine, so your tablet. So you have Android tablet. You need to write the application in Java language and then load it up in the Play Store, and that will develop the app for you, and then people can consume it. They will call it the Google Docs app. Very, very similar to that. If you have the iOS platform, you need to write it in Objective-C or Swift and put it in the App Store, and that becomes the Google Docs app for iPhones and iPads. Conceptually very similar, but language is very different, and the delivery model is also very different. And that delivery model is delivering as a web app. And here you don't use these programming languages such as Java, no Swift, but use HTML, which is, I cannot type T for some reason, HTML, CSS, and JavaScript to create your application look and feel exactly matching what you have in your native applications and render the same experience you have backed up with a cloud-based backend. So this thing cannot run on its own. It needs something in the cloud. So you cannot run pure HTML, CSS, JavaScript in a browser and expect it to function like a native application conceptually without having the support from the cloud end. You need to provide cloud backing to these guys so that they can run. Another example is your Gmail. So if you look at gmail.com, this, I should actually very clearly disambiguate. If you right click on here, inspect element, and go check the page itself, you will see that this is also the same idea, HTML, CSS, and JavaScript. Except, can you tell me how will which part of Gmail, if you look at, will be the client end and the server end or the cloud end? What is running here in the browser for you that you think is Gmail is the client application written in HTML, CSS, and JavaScript, whereas the server end is the website which corresponds to this address, mail.google.com. And so you have the dig mail.google.com is mapping this IP address. And that is where you have this IP address that you have. Where did it go? Not here. So let me get back. So that IP address that you saw is actually running this mail.google.com, is managed by Google themselves. And what they are rendering from that end is what we think is Gmail. But the Gmail application itself is also rendered from the same location. So this entire package containing HTML, CSS, and JavaScript is rendered to the browser when you visit gmail.com. That's what gets rendered the first thing. And so you see that it starts to look like a skeleton that looks kind of sort of like a Gmail, but then there is no email. And then the next subsequent calls back to the server end will then start pulling down your email that you may have received recently, or you filed and accordingly disposed of that you're dealing with that email itself. That action is happening between the cloud end and the Gmail itself. That's what's going on here. So the implementation of this Gmail using HTML, CSS, JavaScript based on these technologies, classically known as the web technologies, it needs a support from the cloud side, which is mail.google.com, something running on the server that is actually serving these elements that the browser will then render and then show you the same experience you would expect to see. The same technology can also and is also implemented in your Gmail app that runs on Android or iPhone. Or you can also configure the same services that you have here running in the cloud to map it to, say, mail.google.com on port number 587 with TLS protocol. And this is for inbound, and for outbound you can configure the same thing as SMTP. Actually, this is going here, so it's 587 here. The port number is 991, I think. And so smtp.google.com. You may have configured these things on your iPhones or Androids if you have them. And so this is where the outbound mail goes, and the actual client, the client that you have in your phones or your Androids will interact for incoming mail with this location on this port and will send outbound email through SMTP protocol on this port using TLS. And that's what the interaction will be between the backend, but your application that you will run locally on the phones will be a native application written in Objective-C or Java or whatever language you have to have on your target device. And so that distinction between web application and native application, I hope, is clear. Is it?
Yeah.
Any questions on this before we create a hybrid solution?
Are some of the people in the course fairly new to compute?
Possibly. Yeah, not fairly new to compute, but to the cloud, yes.
Got it. Okay, thanks.
So the idea behind hybrid is essentially the idea that you take web technology and then put that in form of a native application. And there are tools available in this aspect that will enable a developer that knows this technology to create a native-like application. And that tool is called Cordova. And so this Apache consortium has a platform that converts your web applications into native-like applications. So you can basically continue to use the same language that you know, JavaScript, HTML, and CSS, and create a native binary that you can deploy in the App Store. And that's the idea behind native apps and web apps merging to bridge the gap and streamline your known technologies that you know. So web developers already know CSS, HTML, and JavaScript. And the idea is to take these things and build out a native-like application using hybrid tools. Any questions on this or any other topic you want to cover today? Before we start wrapping and discussing the next thing we want to do, which basically is, I would like you to make sure that you have accounts on a bunch of these cloud providers. And I have compiled a collection of variety of services that are mostly free. And so on this page, you will see that there are links for every cloud provider, which gives us some kind of a discount or some kind of a usage for some time for you to consume these services. And so these accounts are available here on this page. I just pasted on the Slack chat. And so here, if you go to Amazon, this guy will give you a free account for usage for the first year. If you're new to Amazon, if you're not new to Amazon, you probably have already spent that money. Similar to this, Google Cloud will give you, I think, about $300 worth of usage. Joint will also give you something. DigitalOcean is giving you $10 worth of usage through this link, which is basically a referral link. Azure will give you, I think, another trial. And another thing that I would like you to do is we'd like to do some experimentation with these cloud services. So we would like to use infrastructure as a service, platform as a service, software as a service, and play with the concept of DNS. And to play with DNS, we need to have a name. And a name essentially means a domain name. And so I think some of you already have a domain. That's good. If you do not have a domain, please get one. Domains are available for about probably $1. Let's see who's the GoDaddy. Are they giving free a $1 domain? GoDaddy. Probably they will give. So there is a 99-cent domain available on GoDaddy's site. And so you can get a domain that you like, and we will experiment with the key techniques that we have in here. If you go look at Cloud Genius site again, and look at the ideas that we are discussing right now in form of DNS, what I would like us to do is to be able to understand these technologies, such as what's an A record, MX record, CNAME, those things. Not sure if you are familiar with these later parts. Some of you probably know these things already, but the SPF, DKIM, and DMARC, which is evolving, those techniques are new. If you're not familiar, we should discuss that. And then we will understand how do we go ahead and use a virtual private cloud. So we will create a VPC for us in here in Amazon. Where is Amazon? So we have console.aws.amazon.com. In here, we will go and study this aspect of a virtual private cloud. How do we configure it? How do we make sure that it operates just the way we want? And this becomes a very a useful example that we can replicate in other contexts and understand what capabilities does one cloud provider give us from another. So what's the difference between what, let's say, this DigitalOcean guys, what they do not give us compared to what Amazon does, compare that with what Google does or what Microsoft Azure does. We should be able to compare and contrast the overall data center capabilities that these guys provide to us from a VPC perspective. And once we have a virtual private cloud configured just the way we want, by the way, there is a VPC creation is actually very simple in form of a wizard. We just click the wizard and you have a VPC. But I would prefer not to go that route. I prefer that we build our VPC from nuts and bolts. And so there are some steps that we have written down in the write-up here, which you can probably look at in the here. In the module number 10, I think is the current number. Data center in the cloud. There are lots of little videos, about 1 or 2 minutes each. That is what we will cover at some point. We'll also like to go over the idea of understanding and making use of these core aspects from an infrastructure perspective, which is infrastructure as a service. So we want to understand what core capabilities all these providers give us from AWS, Google, Rackspace, DigitalOcean, HP Cloud, and this is a good example for OpenStack, by the way. And you should also see if you can get an account on a OpenStack location called TriStack. I will give you a link in chat. And this site basically gives you TriStack gives us access to OpenStack Sandbox. And they're giving us a free account. But the catch here is that we want to sign up through a Facebook group. So you have to be a member of the group. Only then they will let you access the the TriStack account. So they will give you access, but you have to become a member. And once you are, then you can go to TriStack and log in. And it's a closed group, but that's a add-on benefit of accessing your own OpenStack if you like. That's one way to do that. And once you're there, you can go to TriStack and start using and start making use of an OpenStack deployment available to us from the OpenStack founders themselves. So they're giving us that. If you like, you can use that. And the core idea behind IaaS is we want to understand and study those three aspects that I keep mentioning about, which is compute. Then we'll discuss storage and the networking aspects. So from a networking perspective, we will discuss what a VPC is and how will it help us, what kind of connectivity can lay out, what kind of security implications that we need to apply. Then from a compute perspective, I think it is fairly simple. The idea is to build up a VM and connect to it. That's actually conceptually similar. You basically get a machine instance from any of these providers and then connect to it. That's pretty much it. Then in the context of storage, there are at least two different types. The ideas are you can get storage on the internet, such as this classic S3 simple storage service, or also known as SSS. And the other idea is to have a disk mounted connected to the VM. So this is what Amazon prefers to call it is elastic block storage, EBS. And here you have further distinction in between using a magnetic type, SSD type, or a high performing SSD type. And so that's the storage elements. Then the other idea that we have to cover is the idea between simple storage service and using that to deploy very high performing sites without servers, without using servers. So you can actually deploy sites without servers. Are you familiar with this idea of deploying a site without a server? Are you guys familiar with that already? When I say without a server, I actually mean with a zero VM, so no VM, just storage and deploy a site. Are you guys familiar with that concept?
No, I'm not.
Okay, yeah. So we'll discuss that. Then we will also have the concept from a IaaS perspective. We'll discuss compute storage networking, the core aspects. Then we'll switch over to the idea of understanding, which is relatively new in the industry, which is not VM, but what is known as a container. A container is a different modality of running applications, running whatever you want, and create a platform out of it. And that becomes it's extremely popular these days, known as Docker. And that is a container technology, and we'll go over that. We'll also cover the idea switching off from there to the topic of platform as a service. We'll study Heroku. Heroku is a very well-known, highly respected platform as a service available. This company is acquired by Salesforce. Salesforce now owns Heroku. And like Heroku, we have Red Hat OpenShift. And then we also have a bunch of different open source platform as a services available, such as Cloud Foundry, and that is from EMC. Cloud Foundry is actually, it's Pivotal, not EMC, but it's the same thing. Pivotal.io. They have created an open source product called Cloud Foundry. Then we have DEIS and a bunch of other open source platforms available as a service that are relatively, I should say, relatively easy to deploy, but that can become a case in point where you are into the aspect of when you think that your company needs your own private deployment of a platform, that's the direction you go. You go this way. But if you're okay with living on a public cloud, you can go this way or this way. There are many others, like there is the Engine Yard, which is another platform as a service. And so these guys, Heroku, Red Hat, OpenShift, are public passes, the public guys. This, when it is open source tool sets, you can deploy that in-house, and you can conceptually develop similar to Heroku using Cloud Foundry or other smaller but somewhat easier to deploy platforms as a service, or you can build your own PaaS. That's also a possibility, but that requires new development. And then we kind of the aspect of a software as a service is conceptually trivial, and you probably used hundreds of SaaS already. So the idea that I want to elaborate more on software as a service is this concept that I just covered already, which is the idea of understanding that the native versus web apps, and the hybrid of that, which is I just discussed briefly, hybrid. And the aspect of studying SaaS, I think, is relatively trivial. Unless you want us to go into that, we will go there and we'll study that. If you want to do a one-on-one, that's welcome too. If you, but I will rather not spend too much time on SaaS, because I find it is very easy to comprehend, and I suspect most of you know it already. So having said, that's what we are looking to do in the coming days, is to basically deep dive into IaaS, understand it, and use it in the context of some name that I would like to have. I'd like you to have. So have a domain. We'll configure it through some kind of a DNS service. And by the way, Amazon provides you a Route 53 service for DNS resolution. Wherever you buy a domain name from, they will also give you a service, so you can use that, or you can use a paid service. It's a choice that you have to make. I would stick with the free one that you have when you get a domain for $1. Just stick with that name service that they give you for now, and we'll see if we need to make a change at some point. You can change that. That's also not difficult. But having that name helps us in making use of these cloud resources much more efficiently by treating them as a name as opposed to an IP address. And then we'll go into deeper aspects of understanding compute, networking, and storage elements, building out a data center in a virtual private cloud situation inside, say, Amazon or Google or Azure. And by the way, this not Rackspace, the DigitalOcean does not give us all the granular controls that we would expect. So if you go to DigitalOcean, all they give you is what you see here, is that these boxes. That's all they give. They don't give you the granular level of controls that you expect from a cloud provider. But I think I still like their pricing, and their performance of the machines is pretty darn good. That's the reason why I keep going there. But it has to be understood that they are not a comprehensive cloud provider like Amazon, for example. So that has to be understood. Having said that, that is the plan I have for us going forward. And I would like to hear from you. What do you have in mind? And we are welcome to adjust this, edit this, modify it, and see what makes sense for you. So I'm opening this for questions. If you have, please shoot.
With the...
Yeah, hi, this is Patrick. I just wanted to ask you... Sorry.
Yes, Patrick, go ahead.
I was just going to say about, as far as getting into like Azure and Google, how much content do we actually get into? Are we going to focus most of our time on like AWS? I'm just curious because I just did all that training. And for me, I think Azure and Google would probably be better for me, but I can't speak for the rest of the class.
I understand, and I think from a concept perspective, if you look at the exhaustive nature of services that Amazon provides, and I'm not an Amazon employee, and I'm not taking their side, but if you just look at what Amazon has done compared to everybody else in the industry, this is fairly elaborate. Let's put it that way. Yes, there are some quirks here in terms of how they configure it, but this is a pretty darn fully featured cloud solution set.
Yeah, no, I get that. I'm not taking anything away from the service. It just seems like out there in the world, there's more, from a training perspective, there's more things available for AWS versus Google and Azure.
Yes, true. That is correct. So yeah, I'm agnostic. So yes, having said that, if you want us to focus more on Google, we will do that. I have no problem. If you look at Azure, they how do I say that? Being politically correct. Hold on, let me say that manage.windowsazure.com, and so you will find that. Do you have an Azure account already? If not,
Yes, I do.
okay. So that's good. So you've seen it from inside, and so they have what they have. I don't need to comment about what they have, and the performance, the capability, it differs. So from provider to provider, there are some differences. There are some good points. There are some bad points, and we just need to understand that and make the best use of what is available out there in the industry today. And so this is what you get from Amazon, and I have a machine running here.
Yeah, I mean,
And
I think the thing that would be really valuable if we were able to go over like the differences and
yeah,
do a comparative analysis of of Google, Amazon, and Azure.
yes,
If
I
we were
will.
able to do a
Yep,
comparative
yep.
analysis.
Bingo. I think that's exactly how I think, in fact, because what I think is that we should not be tied to any one particular company, but
Agreed.
instead remain fungible. In fact, this word fungible is one of my domains, and this is the
So
domain.
how do you anticipate maintaining fungibility in the face of the various services that are developed in the PaaS layer? I mean, a lot of those, like if you go back to Azure and you do like Azure services, right? Then anybody that actually leverages any of those services is going to end up with an NCA or a native cloud app for that cloud,
You're
right?
right. You're right. You're absolutely right. In
So
fact,
so then how do you maintain fungibility in that?
that is beautiful question. So I will try to answer that. By the way, so the idea of fungibility is let's put it blatantly honest. Fungibility is hard, like really hard. Let's clarify that. It is not impossible though. Let's put it that way. It is really hard, really hard to accomplish that today. Over time, I think the industry is moving towards making things fungible so that the costs go down, the capacity to afford becomes better, and fungibility can take shape. Today, it is absolutely not fungible. No. Having said, you can accomplish the idea of making things fungible from there are two perspectives to it. And the two perspectives are the customer perspective and the service provider perspective, right? So if you are a service provider, you want lock in, and
Right.
if you're a customer, you want fungibility, right? So that's the deadlock. We have a deadlock right there. And so cloud service providers will continue to identify ways and means to keep you logged in, whereas
Yep.
customers will want to remain fungible. And that's basically that's their standpoint, right? That's their economic benefit, to remain fungible. Now if you take that same idea and refer to a previous example that I mentioned about MySQL, right? If you are able to take MySQL application and use a database as a service, and then use the MySQL database that you give to your application, that's one way. The other way is you have your MySQL, and that you actually install sudo apt get MySQL server on your Linux box, and that you have the box in whatever cloud you want. In that case, if you automate the whole thing through a scripted fashion using something like Chef, for example, and have the Linux box provide you MySQL service to your application, and this is completely hands-free automated. And so if you go this route, this the right side route, and not this, then you have some semblance of control, because now you have literally eliminated who the cloud service provider is. You don't even care. All you care for is whether they give you a Linux box and a machine of the appropriate size and appropriate storage and appropriate connectivity and bandwidth and security and firewall and everything else that goes along with infrastructure. But at the end, all you get is a perfectly secure, nice and updated Linux box. And then on top, you have your own automation through Chef. You deploy your MySQL and you have it configured so that it becomes your own homemade service. How homemade as in office made, work made, custom made service that you run it for yourself. And then you have this semblance of fungibility. Because now, if you think that Azure or Amazon or Google is going to bump the prices, you say bye bye. Literally say bye bye Google, bye bye Amazon. I'm going to DigitalOcean, and I'll run my chef recipe and cookbooks on the DO box, the DigitalOcean box, and run my own Linux. And by the way, I will spend only $5 a month, and I'll get my own MySQL box inside my DigitalOcean cloud, and I have my app running in there. I don't care for the cloud provider, honestly, because that's what they are. They are fungible from my perspective, and I want them to be. However, from the service provider perspective, it is exactly the opposite. The service provider will keep developing and keep incrementally creating new value elements, such as the Azure, that example you gave, or this example of DAS. And so DAS, database as a service, you have the every company, you name it, including your HP Cloud. Where was that? HP Cloud. They started a database service. Microsoft has SQL databases. Microsoft also has some. Go ahead.
Let me interject a question in here that maybe you can hit while you're talking about that. So if you have a DevOps team that has used departmental resources in order to go out and acquire cloud services, and they leverage some of the past services, so they've got an NCA for that app. Is there anywhere that is anybody putting together a list of compatible services for basically doing like cross-cloud conversions and things like that, or even public to private migrations?
So I think the way to accomplish that is in the hands of end users of cloud, in the hands of consumers of cloud, in the hands of customers. The companies that are providing you services, let's go take a couple of examples here in terms of database as a service, right? These guys, they although want to provide, let's go look at this example I have is from Amazon. So let's look at Amazon and see what they do in terms of database as a service. So let's see. From databases of two types, broadly classified as NoSQL versus SQL. And so in SQL, you have these 5 choices, right? You have the MySQL choice, the Postgres choice, the Oracle, the Microsoft SQL, and now this new one, Aurora. And this is Amazon's push towards something new, but it is not open source. Similar to that, if you go back and look at the DynamoDB example, they claim that this is better than Mongo. Now, I don't know, but I think if I am an open source user of databases that I require for NoSQL, I would go with Mongo or Cassandra or something that is open source and probably not tie myself up with this Dynamo. I hear it is good. I'm not questioning its merit, but I need to remain fungible. And in that case, I need to run this. So you have Chef, MongoDB. So I will rather create my own MongoDB deployment using this cookbook and keep it in my control, as opposed to letting my team use this. And this thing is DynamoDB. Yes, it is useful. Yes, I hear it is good, but I have honestly never tried it. And I don't intend to, because that is not the direction I want to go. I want to go the Mongo style. I want to go stick with somebody who is developing MongoDB in the open source domain, and these guys are doing it. And that's the application I would like to run.
Why is the difference? For example, the DynamoDB, the only difference that doesn't accept a nested key pairs. So it supports everything the exact same thing. So if you don't need that feature and you don't have to administer the server and they automatically replicate it across multiple zones, and you have a minimum of 6 copies across the world, and you don't have to administer it, why then not leverage some functionality that then you can optimize your chef recipe, so you can then leverage that, and it's one less thing to manage?
You're right. That's a valid way to think. I'm not questioning that judgment, not at all. All I'm
And
saying
I'm
is,
actually,
if you, it's a valid approach, by the way. Some companies actually actively use DynamoDB, but there, in my perspective, I would rather stick to an open source standard. And this is slightly different from what the MongoDB style dealing with NoSQL database is slightly different. And this is a strategic move on part of Amazon. What they're doing is basically giving you something better than what Mongo has. At the same time, trying to lock you in long term. And so long ago, I think about 4 years ago, this thing called App Engine. I used to have my application running on the App Engine. And at that time, these guys, Google App Engine, it's a beautiful platform as a service available. However, you cannot take your application from a classic open source model of running your app in Java and assume that you have a standardized MySQL database. They use a customized Bigtable implementation here. And so I had to have my developer team rewrite our existing code to fit into App Engine. And then after a few months, App Engine decides to raise the prices. And we got screwed. We had to go back, basically roll back all our code changes and rewrite our way application the classic open source database supports. And that's when we went back away from App Engine and went onto a model where we are running it directly using purely open source and on a platform that we control, not anybody else. And that has been our case in at least 2 different cases. We had applications running on Google App Engine, and we thought it is nice. And yes, it is nice. We thought it is going to be long-term viable for us. And yes, it was for a few months. And that's when we start, we thought that these companies are doing things that are basically in a model where they want to go lock in. And that's a good one. If you're a service provider, you want people to lock in. So that you have the example of Dynamo. You have the example of App Engine. And every single company will like to create something that will enable the lock-in so that they can continue to remain profitable. But customers would like to have this, absolutely. In certain cases, there may be trade-offs. And yes, in those cases, when you don't use a particular feature set, maybe Dynamo is a good one. And if you can enter into a contract with Amazon and ask them to commit to the fact that they are not going to raise the prices, maybe that's a good one. Maybe you can get a special deal with them. And so you can use DynamoDB and stay with Amazon for a certain number of years, provided they are agreeing to A, B, C, X, Y, Z, whatever conditions you negotiate between them. And that negotiated position is rational and is doable, and it's economically viable also. However, it may not be fungible. And so you have to basically understand from an economic standpoint, does that make sense? From an economic standpoint, I did not spell it right, but from an economic standpoint, if it makes sense to you, yes, go ahead and use DynamoDB. Nothing wrong with that. Nothing wrong. As long as it makes financial sense, do it. But without the clarity of economics, fungibility is a good idea. Because you know that you're going to remain neutral. And so take that route. If you don't know what the economic implications are, or if you are too small that Amazon will not negotiate with you, or if they'll ignore you, then you remain fungible so that nobody actually, misuses you. That's how I tend to think. But if you know that they are going to give us a feature set for a certain amount of time at a negotiated price, that you actually like the service that they currently provide, that there is no cost to you on changing your application, on changing your code base, no new learning for your staff who's writing applications, no new learning for your team that will how you deploy, how you maintain your applications, your services. If there is not other costs, the entirety of your cost structure has to be studied. And if that fits in, yeah, it's totally fine. In fact, it is economically rational to go that route as long as there is an escape route. What if something goes wrong? What if DynamoDB does not include whatever we want? What if the terms and conditions fail? So you have a contractual relationship that you establish, and those what if conditions that you will put in place need to account for that, and there needs to be a financial compensation for deviation. So if they deviate from certain things, they need to compensate you so that you're taken care of from an economic perspective, and that's a valid model. That's how companies are able to service and provide solutions that are slightly different and are able to lock yourself in, and that's awesome. I mean, nothing wrong with getting logged in if you actually love getting logged in. Like, for example, I have logged myself into this Apple ecosystem, and so all my things are in the Apple ecosystem, and I have voluntarily logged myself in. So much so that I am running a public beta on production machines. See that? I am running El Capitan public beta, which is going to come after the release. And I'm running it on a production machine. I'm using it with you right now. So I trust them, and I have given myself in. So it's not that I'm always away from a locked garden. This is a walled garden, completely chained off. I cannot do whatever I want here, except as long as Apple agrees. But that's a model I chose, and that seems to be working out for me, and that's what I want, and so that's what I'm doing from a customer perspective. So fungibility is not the ultimate solution, but it's one of the guiding principles when you make an economic decision. Does that answer your question? Right? Are you there?
I'm not sure if I was the one that asked the question or I jumped in someone else's question.
Sorry, I missed that. It was a lot of echo coming up from somewhere. But go ahead.
No, good. I don't know if I was the one that asked the original question or I jumped in someone else's question.
It's okay to jump in, man. It's okay. Yeah, it's okay.
Nilesh, I just had a quick question regarding the expectation for watching the videos through the dashboard. How many modules do we have to watch? I mean, how do we map the class that we're in compared to the modules listed here?
So the modules listed over there are designed for people who have no idea what cloud is. And so you are welcome to skip through. You're welcome to go back and listen, but there is no set requirement. The next thing that I will actually summarize to you in email as to what we will be doing the next time. And to start, I would like to make sure that all of you have access to a Google account, a Google Cloud account, a Amazon account, a DigitalOcean account. So that link that I pasted here, I'll paste it again in Slack chat, should be giving you a link to all the infrastructure as a service sections. So in the Slack chat, you have the link on cloud infrastructure related services. So I would suggest that you please create accounts with these guys: Amazon, Google, DigitalOcean, and Azure. The four ones. Joint, we can skip if you like, you can take, but these four: Amazon, Google, DigitalOcean, and Azure. Please create an account, and we will start experimenting with the infrastructure as a service section the next time.
Are you sending out those links in the email?
I think I pasted in Slack chat, but I can send you an email if you like. In Slack chat, there is a link already called service accounts, the very last link from me.
Oh, okay, right. And so they're all on your website, right?
Yeah. So all the web, this website has links to all of that. So it's one page containing all the places where you can get a free account to begin with. It may not be completely free. There may be some cost to you. So you have to read carefully. These are service providers that tend to give some free trial, some free amount, maybe for a year, maybe for a month or so, something like that.
Hey, Nilesh, this is Ted. This is the first day I've ever used Slack chat. So if I were to exit Slack chat and then log back in tomorrow or later or whenever, our conversation and all your links would still be there, right? Or would they be erased for posterity?
They do not go away, but they will, let me warn you, they will go away after 10,000 chats.
Okay. We better hurry up then. Okay.
Yes.
Just kidding.
Yes. So you are welcome to continue the conversation in Slack chat. I will pause recording and put the recording out in the shared folder that you may have. You may have received a link for Scratch, and I think I saw. So we still have not everybody synced with the recording folder, not everybody synced with the Scratch folder. So please sync that. That will give you access to recordings as well as my handwritten notes and anything else you want to chat. You can continue chatting on Slack and let us meet again. And in the meanwhile, please create accounts on the infrastructure services and let us focus deeper, understand what these providers provide and make use of, understand storage, compute, network capabilities, understand a VPC, see how we can put together a private cloud for ourselves, a virtual private cloud in the context of any of these companies. They all give us similar, conceptually similar. We'll compare and contrast, understand, go deep dive in comparing provider A with provider B and see if you need. And so if you have any other cloud provider you have in mind, like HP Cloud, you can, I'll add a link to HP Cloud also. They also give a free, apparently. HP Cloud free trial. They also have a free trial, it seems. Let me drop, there it is, HP free cloud credit. Copy link. I don't have that free cloud credit apparently, but here is a link coming up in Slack chat. So get that in Kumo private group. That's where you can get HP Cloud also. They're also giving for free. These guys are competing. They're competing because they want your attention. They want you to deploy your applications in there. And so that's why they are giving you this money, and so does everybody else. And so make use of these things. Let us understand, compare, contrast, and go dig deeper. And keep the questions coming in chat. Questions can be one-on-one, questions can be group conversations, any of that is welcome. And after this, I will suggest that David please call so we can talk.
Okay, that works.